So if I ask you, if you were supposed to design elevator system design, you are in an interview or you are given this homework, how would you get started? What would be your starting point? If you are the one who is designing, where would you start elevator system design? Anyone?
The flow of application.
The flow of application. Okay. What is the flow of the application when it comes to elevator system design?
State pattern.
Pattern.
So first, I would prefer to get the requirements for the elevator.
Very good. So obviously, right? So please don't jump to code or to design patterns or classes or anything without requirements. I can see some people saying Tushar, Piyush and all saying requirements. Yes, very good. So we all know we have to get started with requirements. An elevator especially can have a bunch of requirements. So you have to discuss them. That what is the expectation of your manager or your interviewer? So we have to talk about requirements. So what would be the first question that you would ask if you were designing elevator system, like requirements wise?
So is it a single elevator, or are we going to control multiple elevators by this system?
Good. Okay, so I am giving you the requirement. There are multiple elevators. Great. So we know there are multiple elevators. What is the next thing? So very good. Rama and Rekha are saying, so Rama is saying, who are the users? So that is a good point. Who is using our system? Are we also designing for, say, admin or for anyone else? Let's say for now we are designing for our customers. Okay. So we are designing for our customers. We can talk about what things admin would do or we would keep it in mind. But for now we are designing for our customers. That is the first thing. Second thing, yes, there can be multiple elevators. Someone is asking how many floors. Okay, now my first question to you is that first of all, you are designing a system, right? So suppose there is one building and there's another building. So is it different system for these two buildings or same system for the like two buildings? If I have say 10 buildings, is there same system or different systems?
Same.
How many of you say same? Just let me know in the chat, same or different.
That depends upon the requirement.
That depends on the requirement. But see, again, I had given you this tip earlier also. In your interview, you have to drive the discussion as much as possible, right? You have to give a particular reasoning that why you think it should be same or different. And there is a high reason that, your interview is going to be okay with it, or your interviewer is going to cross question you. So you have to give reasoning behind every decision and you have to ask, is this okay? Can I assume this? Right? So if you were a candidate right now, would you say same or different? So I can see a bunch of people saying same.
Same. I will consider same.
So for different buildings, same. But if you think about it, then if it is same, then don't you think you are involving network for no reason? Like you will have to communicate over network. You will have to take care about high-level system design. Is it really such a complex topic that you have to talk about high-level system design and network and all of that? Why can't you just have different systems or different codes running for every building? Especially, remember that we are discussing low-level system design.
Correct. If I am considering it same, then my understanding was the flow, the functionality will be same in all the elevators of different buildings. It's not that from the centralized system we are monitoring, means controlling.
Should obviously be same. So my question was that the system is going to be same or is it going to be different? So, okay, let me explain this point. So if I have an elevator system, this is per building or is it the same system? Like if I have say an instance of elevator system, will it be accessed by different buildings or is it per building? Centralized system or not?
It's per building.
Per building? Everyone agrees to this. It makes sense, right? To have per building. There is an elevator system per building, correct? So we have discussed that in every elevator system, there will be multiple elevators. What next question can I think of? What else should I ask?
Should we consider like
do we have an
underground
emergency
source?
button?
Like,
emergency button. See, these are very, very specific questions, right? Like Inside elevator, there will be a fan, there will be say light, there will be say emergency button, right? And there will be a bunch of things. But are these the most important questions for low-level system design? Okay, there is power backup, there is speed of elevator. I can see people talking about this. I am asking you to ask requirements for low-level system
Are
design.
there any underground floors? Like, should we consider starting 0 or should we consider negative floors also?
Okay, range of floors.
So
The
my question
movement
would
of
be,
elevator.
when we talk about customers and the buildings, right? So are the elevators we're designing, are there for let's say some builder flats or something like that, or they are meant for hotels or something like that?
Very
So
good. So there are
who-
basically different kinds of elevators. So there are passenger elevators and service elevators,
Yeah.
correct? And there are also say private elevators. If you have seen that this elevator should go to this floor only, there's something like that, right? I can see people talking about capacity load and maximum load in the chat. So I'm adding that also, maximum load. Yes, these are the points that you should discuss. Even in elevator, you should talk, okay, there's fan light, there's emergency button on all of this. But in terms of requirements, say you have 1 hour, okay? What are the main things that you're going to ask about?
Yeah,
The
one more
movement of
question.
elevator. Suppose
about
if
the movement?
it start from ground floor and someone pressed the button of at 5th and 7th, so will it go to 5th and then 7th? I means it will complete the whole cycle. Suppose it is a 10-floor building, so it will complete a whole cycle and from ground to 10th, or it can suppose I have 2 elevator and one person has pressed at 5th and another is pressing for 7th. So one elevator will go to the 5th floor and then it will come down, or it will go to 5th and then 7th and then it will come down.
Very good. So I can see a lot of you are talking about algo for movement. Now I will need 5 minutes silence from everyone to explain you something. Okay, so I am the one who is giving you requirements. So let me just tell you, you don't need to know this. I'm just sharing with you that for elevators, see, there are different algorithms that can be there. There is first, say, first come, first serve is one algorithm. First come, first serve means what? Say, suppose I'm on floor first and I press 4th floor. Okay, so I should go to where? I should go to 4th floor. But say on 2nd floor, there's another person who came and wants to go to 3rd floor only. But because first come, first serve, because this person came first, I will first go to 4th floor, then come to 3rd floor. Doesn't make sense, right? That from 1st floor, I'm first going to the 4th one. I could have just stopped in 3rd in between, right? So first come, first serve does what? That whatever request came, you will go to that destination first, and then you will go to the next destination. Everyone understood what is the meaning of first come, first serve? That if I am saying the first request was to go on 13th floor and the second request was to go on 10th floor, and I am presently say on 2nd floor, I will first go to 13th floor, fulfill this request, then I will go to 10th floor. Whichever request came first, I'm going to fulfill that. So this is one algorithm that you can do. Another famous algorithm is, it is called shortest seek time first. So let me just write it down. Seek time first. So basically what happens is, here the distance between say the source floor and the destination floor is calculated. So whichever distance is least, that one is fulfilled first. Can anyone guess, whoever knows DSA, what data structure can be used if I want to sort according to say distance?
Priority queue.
Yes, so I can use priority queue or min heap or something like that, right? So this is another algorithm. There's another algorithm which is called scan algorithm. So now what happens in scan algorithm is that that is what you were talking about. One of you were talking about that if I am say on this floor, I will go on top, then I will come down, then I will go up, then I will come down. And in between, whatever was requested, this was requested, I will stop. If this was requested, I will stop. And in between, if this is requested, it is fine. I will go up and then come down. So it is like go up, come down, scanning, right? So from down to up, then down, then up, down. It is like that. Then there's another algorithm, which is like the better version of this, which is called the look algorithm. So in this scan algorithm, what I was doing is I was going till the top floor, even if I did not have to go to the top floor. Basically, if say there are 18 floors in my building, 0 to 18, I will go to 18th floor every single time. In look algorithm, what I'll do is I'll go till the last floor where I have to go. Like suppose the last request is to go to the 10th floor. Why should I go till the 18th floor? So that is the only difference. See, the point is not to talk so much about algorithms. The point is that they can be different algorithms, right? They can be different algos for movement. Now, as someone who is giving you the requirements, I want you to support different algorithms for lift movement. So I'm just writing it down. Different algos for lift movement. So basically, I've written live for lift movement. So basically, as an admin, someone should be able to set that this is the algorithm that can be used. Suppose in one building, I set that I want to use FCFS algorithm, and in another building, I say I want to use look algorithm. I should be able to do that. So this is one of my requirements that I'm giving to you. Does this make sense to everyone? Any questions over here? Any questions? No? Okay. So we have talked that elevator system is per building. Then in every building, there can be multiple elevators. Then we said that there can be different algorithms for lift movement, right? What else should I talk about when it comes to?
Does our system support some third-party service integrations? Like we have ACM services that would automatically detect if something is wrong with the machine and do the needful.
Okay, so maybe automated systems and integrations.
Correct, third-party integrations. If we have.
Okay. So I have not coded for this, but I'm just writing it down. Okay. I have not coded. Yeah.
Yes, let's say
Like we can have a status whether the lift is for under maintenance or not.
Yes, that should be there. Definitely. So what is the status of the lift? And also not just under maintenance. Okay. Let's say for now only this. I'll talk about the status more later. Yes.
you could have for like idle, up, move, up, down, and this under maintenance.
That's what I was about to say, that they can be status, they can be direction, what movement, but those are code level details. I'm not talking about code level details. Anything else I should talk in terms of requirements? Anything that you can think of? Okay, alarm, emergency services, yes. There is one very, very important point in terms of low-level system design that you guys are missing. Okay, let me talk about it. Multiple elevators. Does this ring a bell?
Will a single building have multiple elevators and will they be connected together or not?
So we already said that there will be multiple elevators. But now the question should be that when you press a button, when you call for an elevator, will all the elevators come? Will one elevator come? How will you decide which elevator is coming? So as a user, think every time you start designing a system, okay, you said that was a very good point that some of you said that we have to see for whom are we designing, for the customer. Okay, let's start thinking what the customer does. That for every system, this is how you should be starting. Okay, this is a very good point so that you do not miss anything. Start like this. I am the customer. How will I use this system? I will first go in front of lift and I will press a button from outside. Yes? Yes, everyone? Now when we do this, when I press the button, what do I press? I press either up or down. So what am I giving? I am giving direction, that which direction I want to go to. Also note that I will be at a particular floor. So my system will come to know that what is the source floor. Basically where this, where the lift has to stop and pick up a person, source floor. Correct? Make sense? So now I have pressed. Now what is going to happen? Suppose there are, say, 5 lifts over there or 4 lifts over there. I live in a big building. In my floor itself, there are 4 lifts. Now the system has to decide that which out of these 4 lifts is going to come. Yes, I am not talking about the movement algorithm. This is per lift. That one lift, how is it moving? Right now, what I'm asking is that if there are 4 lifts, will all the 4 come? Will any one come? Will 3 of them come? How does that work? Do I make sense?
the lift which is coming is going in that direction and which is closest to the source floor. I think that would be selected as the best lift.
Good. See, the thing is that I want to make my system very, very extendable right now, very, very maintainable. It should be like I should be able to use it in any building. So like over here for movement, I had different algorithms. I want you to support different algorithms for selection of the lift, selection of elevator. That if there are 4 elevators, you should be able to select that which one will, if this one comes, suppose not just that it is moving in that direction. Let me give you an example. Suppose I'm in 10th floor. Now there's one elevator that is coming up from the first floor, but there's another elevator that is over here, say on the 3rd floor. Okay, well, it is not moving anywhere, it is just standing. So should this one come or should this one come? Similarly, say there's another one who is coming, say from 13th floor, which is coming down, right? So I should be able to support different algorithms. Now, let me tell you what are the different algorithms usually. In some buildings, now what happens is that suppose I'm standing on the 1st floor, then say I have 4 lifts, right? 1, 2, 3, 4. If I'm requesting from 1st floor, say 1 or 3 can come. If I am standing on the 2nd floor, 2 or 4 can come. Basically, odd even selection. You understand the point? That some lifts will cater to the requests that are coming from odd floors, and some lifts will say cater to the requests that are coming from even floors. Make sense? Yes, like odd even in Delhi. Everyone is able to understand, right? The requirements that I'm giving. Hello. Also, I am making you think of it, that how can I make my system more extendable? You have to think of what is the user flow. Customer came, like the user came, pressed button. Now the lift is supposed to come. There are 4 lifts, so I have to choose. One is odd even strategy. They, like some buildings also have zones. So there are zones wala strategy. Like if you have seen some buildings, they are like this, right? Octagon shaped or hexagon shaped, something like this. So it will, so suppose there are 2 lifts over here. So if the request is coming from, say, some one zone, then these 2 lifts should come. But if it is coming from this zone, then these lifts should come. So basically, they can be odd even strategy, they can be zonal strategy, they can be different strategies to call which lift should come. And after that, like how will the lift fulfill? That is this movement algorithm. So I'm talking about 2 different algorithms. Make sense? Any questions still here in the requirements that I'm giving you? Hello.
We
Yeah.
needed a number of requests also, right? So based on number of requests, how many lifts needs to come down?
Oh, the dog is actually moving his face the way when you're talking. That is so cool. I'm seeing this for the first time. So cute. Okay. Okay, yeah. Sorry. I did not even hear the question. Can you repeat that?
So it's based on number of requests also we need to combine. So
Yes. Yes. So based on some factors, I should be able to choose that which algorithm I'm going to run. Maybe there can be multiple factors to which it contributes, right? The point is that you should be able to support different algorithms. Good point. Yes?
So we're not supposed to write any algorithm in system design, right? So just design the system, support multiple algorithms, and in classes just print some dummy value and go back, right?
Yep. See, let me just clarify this point also for interview perspective. Some companies nowadays, what they have started doing is that they combine DSA and LLD round, and they will make it one big round, one either 2-hour round, or say they will give it as a project or a homework. And in that case, you should ask, right? Always in LLD, be sure that you are asking, communicating with your interviewer, what is the expectation? The usual expectation in LLD will be that you just say that this, like there will be like some algorithm, but suppose your interviewer is too much into DSA, wants to test, maybe at least wants you to say that how would you approach this problem? Like for example, over here, I gave you 4 different algorithms, right? Like you can just say that there can be multiple algorithms and you should just be able to tell that maybe I will do first come, or maybe I will do like this, like I will scan up and down or something like that. You should be able to come up with approach. Maybe that is the expectation. Or maybe you can, like one of you were telling right now, right, that I have to make the decision on some factors, like how many requests have come, what is the capacity right now, how many people are already there. Maybe based on some sensors, I'm going to make the request. Maybe your interview is expecting you to talk about it. In system design, always it will take you literally 3-4 extra seconds to quickly ask that I am going to assume that, okay, these are like, I'm assuming that you don't expect me to talk about the algorithms. I'm just going to assume that this is how it's going to work. I'm focusing on making my system more extensible and maintainable. Is that okay? 99.99999% your interview is going to say yes, but your interviewer will also be impressed that you are making sure that you ask again and again that what is the interviewer expecting, and you have to ask. Is your interviewer expecting you to, talk about the algorithm? Maybe it is a long interview. Maybe the system is very, very simple. Right now we're talking about elevator. Maybe it is say something like chess or tic-tac-toe, and your interviewer is expecting you to talk about the algo, right? So you have to talk about these things. Cool. Okay. Any other requirement that you can think of, or should we get started for now and let's see as things go on? More or less, I think we are good to go. We have talked about the requirements. Yes? Yep. Okay. I'm starting. Atul Singh, can you please give relatable examples with Burj Khalifa elevator? Why Burj Khalifa? Like it should work anywhere. Elevators will be used by all. What is this requirement worth? What does the question even mean?
What do we mean by this requirement? Like elevators will be used by all. Do we mean that it doesn't have an access ID card or something like that?
Sorry, what?
Like the requirement is elevator should be used by all. So what is this require? Like is this even a?
It should be used by all.
I think we discussed something regarding who is using the elevator.
I said that they can be, say, admin setting up some things, right? So when we are doing, say when we are designing our methods, is my admin saying that run according to this algorithm, stop using this elevator, mark this elevator under construction, something like that? Or are we only taking care about, the basic requirements that customer is going to do, press button, ask for elevator, go inside, go to the floor, get out, like that? Make sense?
Okay.
You have to think about different users of the system. There has to be an admin, especially in low-level system design. A lot of times, people like your interview is going to expect that you think from the admin perspective also, and you make your system extensible. That probably this can be used by my admin. So you have to think in that direction as well. Okay, cool. Let's get started. Let's, more or less, I think you have understood the requirements. Let's start talking about the different classes that we are going to have. So if you are designing the system, which class would you start with? Which class would you start with? Shivangi, admin. Love is saying facade. Okay.
Floors.
Okay. Someone is saying elevator manager, controller, elevator factory, client. Okay.
I'd like to go from bottom up, starting with the elevator, then thinking about the manager layer, and then layer wise, I want to move to the client side.
Okay, if that works for you, okay. But I will tell you what I do usually. That is what Preeti has said. So I will first write, yes, Hemant has also said it. So basically, I will first write down what all things can happen in my main, my customer. What all things is my customer going to do? So I will basically have steps that these should be the things that should be running. And then I will think of, okay, these are the high level main classes, and then I will drill down. That is usually how I do, so that I don't miss anything. Okay, otherwise what will happen is if I start from bottom up, I might start talking about very small details that might not matter in the end. See, especially in terms of interview, you have 1 hour. It is okay if you miss details, say like in elevators, there's a fan, is there a light, is there emergency button? What is going to happen is that if I start from elevator, as most of you were saying, Prerna was saying, Abhimanyu was saying, you might get worried. Like, this is my perspective. Let me know if I have any other perspective. If I start from elevator itself, I will start thinking about these details. There's a light, there's an emergency button, this. And then in the end, the main thing that I was about to do, that like, deciding how the system is going to work, how the algorithms are going to work, how my, lifts are going to go up and down. I will end up missing those. So that is why talk about high level so that you don't miss anything. Do I make sense? Abby is saying that you mean just consider user flow, story, note down in main. Yes, exactly. Yes. So basically, my main is going to do what? Firstly, we talked about elevator system. Now, Love mentioned facade, and I like that point. So basically, if you think from main, okay, so now the question is that who will main talk to? Will main have access to directly elevator? Like, so suppose I am a customer, like you're designing for me. Do I go like, I press the button? Where does the request go?
Elevator control system there should be a class that controls the elevators. So the request would go there first.
Yep. So say I am calling it elevator system. So there is one system that my request will go to, right? So okay. Also, one more thing that you guys should talk about, you should think about, that when we talk about elevator system, I will say everything that elevator system should take care of it. I don't know how it is going to take care of it internally. That is what facade means. Yes, it's just a term, right? That for me, I am going to talk to elevator system. I don't know how it is going to work inside, what is going to happen. So you can sort of think of it like a facade, because Love mentioned it, I am also mentioning it, that I am going to talk to one system. How things are going to happen inside, I don't care. Make sense? Yes, no? Yep, okay. Now, elevator system, what are the kind of requests that the user is going to give? For me, so, okay, Rama is saying elevator system.start. So in the starting, I will have to initialize my elevator system. I will initialize, probably I will set the algorithms that will be used and all of that, right? So let's say we have done the initialization part. Let's come to the using part. So the customer will now make a request. So I can see Naveen and Mahim saying up, down, then floor number, call elevator, floor number. Yes. So say something like, it will look something like this. That's system dot send request. And what is my request? There is one direction. In the direction I am mentioning whether I want to go up or I want to go down. And at which floor am I? So basically source floor. Make sense? Yep. Does this make sense that this is what user is going to do? Now, this is one thing. Now I get inside. What am I going to do next? I suppose the lift came. From the user perspective, what do I do next?
Destination
flow.
Select the destination flow.
Yes. So now there is one very important point that you guys should remember. There are two types of requests that are coming in, okay, into our system. One is basically, you can think of it like an external request. What is coming in an external request? What, in which direction I have to go? And what is the source floor? And when you get inside, which is basically the internal request, I just press the destination floor. Does this make sense to everyone? This is a very important point. There are two different types of requests that are coming in. Now, what is the difference between these two in terms of the system? Let's try to think about it. When it's an external request, we also have to decide that out of the, say, 4 or 5 lifts, 4 or 5 elevators, which one is going to come down? That is there, right? Plus, when I get in, I will have to press the destination floor also. If I don't press, then it will not move. This is one thing. Second thing is that for my lift, if you think of my lift, it doesn't matter if it is a source floor or a destination floor. For my lift, probably it is the same thing, that I have to go and stop at that floor. Let's forget about the capacity part for now, that we have to check that is the capacity full and all of that. For now, let's try to forget that. But if you think about it, in the end, what lift has to do is, that it has to come and stop at a floor. It can be a source floor, it can be destination floor. Does it make sense? I'm just trying to make you think about the different kinds of requests and what is going to happen. Yep. Yes, no. Why such less, like no enthusiasm today? Okay, there is a lot of yes in the chat. Okay, thank you. So basically, let's say there are two types of requests. So basically, I'm going to call these external and internal requests. So in my external request, I'm going to say direction. And where am I where I am pressing this? So source floor, right? Next thing what I'm going to do is that I can probably send internal requests. And in that, what I will be inside the lift, right? So I'm inside the lift. So basically, I will be in a particular lift. So say, for example, I have elevator ID. That I am inside this lift, and now I am telling the destination flow. Does this make sense? This is what we have to support. Ravina is asking, multiple people will press multiple buttons simultaneously. How to handle these requests? Good point. Now, I might want to stop at, say, 10 different destinations. How are we going to add those requests? How are we going to deal with them? We'll talk about it. Yep. Does this much make sense that we have two types of requests that we have to deal with? Yes, no? Can I move ahead?
What will the use of elevator ID here?
There will be like many elevators, right? So there are 4 elevators. So you have to know which elevator you are inside, right? Elevator 1, 2, 3, 4. There are 4 elevators in the building. How will you come to know if there's no ID?
Sorry, I
Okay,
have.
for external, that is okay. But if I am inside any elevator, then only thing which will matter to is the destination floor where it needs to go.
So, right. So only destination floor is there, but who, like, from where the request is coming, like from the user is inside an elevator, right? So if you think from, so there will be an elevator ID, no, that we are inside this elevator. This is the one that is generating the request.
Kit, so I have one question. So I want to support two types of requests over there. I don't do internal request. Some of the companies, some of the offices don't have the internal request. When they are entering into they press which is the destination floor. So it will take to the destination floor itself.
So we can have, so yes. So you can have that there is no internal request, in external only you're pressing the floor. Is that what you're saying?
Yeah, yes.
Yeah, so you should be able to have that also. So basically over here, you have, say, source floor and destination floor. Good point. So you can support probably say all 3 types of requests. You should be talking about these things. Yes. Cool. Okay. Now coming to the main classes. Okay, so we talked about that there is going to be an elevator system, right? So there is one class. Now this is the class. Yes.
One question from my side. So let's say, can you just scroll up? Let's say we are saying that for the internal request we have multiple users. They want to land it into the different floor. So that will be the different case, right? I mean, we should support the multiple destinations in that case, and the users that should
basically those will be different requests. So my system will send different requests that inside this elevator, this is the destination floor. Now, one person is pressing or 10 people are pressing, doesn't matter to me. I should be able to support these two, correct?
Right. Okay.
But inside the lift, we can have both the people, right? Some might go up and some might go down. So don't you think that direction is also should be same?
Yes. So we can have different algorithms for this. So we'll have to discuss that. How can we support?
No. So in the internal function, don't you think as a parameter we should be passing the direction also?
No. Because if you pass the parameter, then that means you are thinking that somewhere you are going to use that direction, isn't it? But here we are not going to use the direction. No, the algorithm will decide in which direction the elevator is going to move based on the destination which we have.
Yep. You are just giving the destination floor. How the elevator will reach somewhere, that is elevator's problem. That is the system's problem. Right now we are talking from customer perspective.
Okay.
Yep. Okay. So we know that there is one class called elevator system. we know that in the starting, we have to say initialize it. So there will be one function, say initialize. We will also probably set some algorithms in the starting. We'll talk about this a bit later, probably, right? So this is one method. Now inside this, we should also send external request. And we should also send one internal request. And we already talked about that in external request, there is probably going to be a direction and source floor. And here there is going to be a destination floor. And as he said, probably there can be another one, which will be another send this, and there can be direction, source floor, and destination floor.
Kirti, one question. Sorry to interrupt. So this setting of the algos will be also inside the client.
So setting of the algos will be inside the client. So basically either this part, the setting of the algos, either admin can do, right? You can do that. But for now, because there's like a big system that we have to do, let's say in the starting of the system, while setting up the system, we do this. We are setting the algorithms. If we were, say, designing for admin also, admin could be calling this. Yep.
Okay.
Yes. Okay. Okay.
So, hello. Kirti, here, external request, why it is called multiple times?
There is one requirement that he gave was that maybe from outside only, I also give the destination floor itself. I don't go in and then press 1, 2, 3, 4 like that. Outside itself, there is, say, a keypad and I press. So there was another requirement that came from one of you. So there can be two types of external requests. I've just written them down. Even in my code, I have just coded for this, the code that I'm going to show to you. I'm not coded for this, but someone mentioned, so I just wrote it down. Okay.
And the second one, why you need direction then?
This is not direction, this is destination.
It's destination, no direction.
Sorry for my handwriting.
No, I mean the send.
Okay, you're right. We don't need direction. They will be just source floor and destination. You're right. Correct. Thank you. Okay. One thing that I guess a lot of you are noticing already, that customer is talking to elevator system. Any design pattern that comes to your mind over here? Just one thing that I would like to say. Any design pattern?
Builder.
Why?
No, not probably builder.
Strategy.
Command.
Observer.
Like, say all the names. Out of 80, there is one that I am talking about. I am
There
talking
should be
about
only one instance.
Yes, thank you, Shivangi. I'm talking about one instance. I want only one instance of the elevator system for every building, right? I'm talking to only one system, singleton. Make sense?
Yeah.
Yep. Okay. So here we can use singleton. I've used in my system. Okay, cool. So now elevator system is basically my facade. It is my singleton instance. There's one instance that I'm talking to. Now this guy has to take care of everything, the elevator system. So we all know that there is elevator class, right? Let's quickly write the things that are going to be there inside the elevator. Can one of you quickly tell me what are the different things, or you can tell me in the chat?
Status.
Okay, good. Okay, so now in LLD, another thing, okay, we have to always, whenever we have things like status, direction, what do we use?
Enums.
Yes. So always, like especially in LLD, we have to have enums, right? So what will be the common enums over here? Say direction. I know in direction you will say that there is only up and down, and they can be say idle. Obviously, there's going to be no left, right, and all of that. But it's okay. It's always better to have enums. Okay. Then there can be, I can see some people talking about status. So what can be the status of the elevators? They can be idle. They can be moving. Say not working. What else? What else?
Under maintenance.
It can moving under maintenance. We are not working under maintenance. Same thing. Yes, something like that they can be. So there is one status. What else? What other enum will I need? They can be current floor and all of that. So, okay. Now in elevator, some of you are saying they can be current flow, current status, current direction, and things like this. So what I have done in my code, I'm just telling you that there is one elevator class, correct? Now inside elevator also there is so much that happens. There is capacity. Inside elevator there will be buttons. So there will be an internal button. There will be display. So let me just write these things down. So there is a display. Now they can also be multiple displays. Like for example, there can be multiple doors also, right? Inside one elevator. So maybe there are multiple displays. There is a list of doors, right? Then there can be say capacity. There can be say light. There can be multiple things. Obviously there's going to be an elevator ID. So now what I did was that I created another class, basically another class. And what is the importance of this class? I've just called it elevator state, because there are multiple things inside the state. There is say current direction. There is current status. Current status meaning that is it moving? Is it idle? Is it not working and all of that? And current floor. Where is it presently? Why have I made a separate class? Because these are the values that will be changing very frequently. And these might be required in a lot of places. That what is the current state of the elevator? So the elevator state. Does it make sense, everyone? Yes, no? Make sense? Cool. Okay. So elevator has elevator state. Can anyone guess the relationship between elevator and elevator state?
Composition.
Yes.
Composition.
Very good. Very good. You guys are making me proud. So there's a composition relationship. Why composition relationship? So elevator has elevator state. Can the elevator state exist without elevator? Would it make sense? No,
No.
right? So the entire life cycle of elevator state is dependent on the elevator. So that is why I made this composition relationship.
So
Makes
this
sense?
would be bridge DP, right?
Bridge. Why?
I mean, you're decoupling functionality from a class to another class, right? And establishing a
In
bridge
bridge,
between them.
what do we decouple?
I mean, the only
Action?
difference here, we abstract out the implementation and the abstraction, right? So since we are having a composition here, in bridge we have an association.
You can see, don't use the term bridge design pattern unless you're actually abstracting out the implementation. But we are doing sort of the similar thing. We are abstracting out state.
Okay.
Yes. Actually, interestingly, next point comes to that. In that case, you can say that I'm using bridge, but I have not used the term bridge, but good point, yes. So what I've done is I have also made another class, which I have called elevator controller. See, basically there should be one class which controls the movement, which is responsible for, okay, you are going to do the movement, move to this floor, do this, then do this, and also the different algorithms, right, for the elevator. Remember? FCFS, SSTF, scan, look, and all of this. So there are multiple algorithms that are possible. So all of that will be taken care by elevator. So inside this, what I did was that I have another elevator controller also. See, because my elevator itself had a lot of responsibilities, it has a lot of variables, a lot of characteristics. So elevator state does what? It is going to have the current state of the elevator. What does elevator controller do? It actually controls the movement of the elevator, that move. Or basically there's going to be a hardware for the movement, right? So elevator controller is the one that is going to actually tell the hardware that you need to start moving now. Does it make sense?
Kirti, one question. So, is the relationship not reverse? Like elevator controller controls multiple elevators. Is that not the?
So now the question is that will the elevator controller control multiple elevators, or elevator controller will be for per elevator? So how I have designed is
Per elevator,
every
I think.
elevator has per controller. So basically I should also be able to have different control. So every elevator I'm going to say that you move now, or my controller will have say a list of elevators, and then inside that probably I want different algorithms for different elevator. Then I would have to do a lot of things. So instead of doing like that, I have done elevator has elevator controller, and they will be per algorithm for every elevator. Does that make sense?
So there will be a different entity to control the requests from multiple users, because in the elevator system we had send requests, right? So there can be multiple requests for multiple elevators from multiple users. So is there a different entity altogether for so the elevator controller is not the one doing that, like basically dispatching requests to multiple elevators?
Yep. So
That's
I
a
guess the
different
question is that when the send request comes, where is it going, right? How is it reaching the elevator?
Yes,
We
yes.
stitch it all together. So that is not what this guy is doing. The elevator controller is basically telling the hardware that you need to move. That is what this is doing. We'll stitch the request and all of this together. Just give it some time. Okay.
Another question. Can we rename this elevator controller to elevator manager? Because controller is usually used like in APIs, right? When some request is coming from outside, like MVC, for example, in the MVC architecture.
I have another elevator manager also. And usually what you do for elevator manager, when there's a manager, there are a lot of elevators together.
Right. Okay.
Right? Okay. I can see some people are getting confused with jargon. Don't worry, I can call it anything ABC. For now, think of it like elevator controller is doing what? It is controlling the movement. Or just think of it like elevator movement controller. Does that make sense? Does that make sense?
Yep. One small question here, right? So why do you have a composition relationship of elevator and elevator state if you're already having an elevator manager? So why not keep them completely independent?
I've not talked about the elevator manager yet, right? So give it some time.
Okay.
Yes. Okay. Cool. So everyone understands that elevator has elevator state. Elevator has elevator movement controller or controller. Yes. I know it will be overwhelming in the starting, but it will be clearer. And it is not necessary that my design is 100% correct. There are different ways of designing this, and they can be like many ways. You could have one outer thing, and then there will be many elevators inside that. We will come there. Okay. Now, what will be the relationship between elevator and elevator movement controller? According to what I said.
Composition, because we are having per elevator.
Yes, we are having per elevator, and obviously this is controlling that elevator. So obviously elevator has movement controller, and movement controller cannot exist without elevator. Yes. Love is saying I'm probably the only EE over here. Love, I am also from electrical background, by the way. But okay, cool. Moving on. So we know this much. Okay. Also, since we're already talking about movement controller, let's just finish one more thing and then stitch the entire request together. Okay. So now we are in movement controller. This movement controller is supposed to adhere to different algorithms for movement of the elevator. The different algorithms that we talked about. Scan, first come, first serve, look, shortest seek time, and all of this. So I guess a lot of you can already guess what design pattern am I coming to?
Strategy.
Yes. So there can be different strategies for movement. So what I have done is I have made one elevator control strategy. Basically, I'm controlling the movement. Okay. The name would become too big. That is why I'm writing elevator control strategy. It has one class. It has one method. So what is the method called? It is an abstract method, basically. Okay. I had initially called it move, and I think in the diagram it is still move, but I had renamed it later. Let me just check. I have not renamed it in the diagram, I think. Give me 1 second. Elevator control strategy. So I have renamed it to determine next stop, because I thought that move will basically confuse you. Right now I'm calling it determine next stop. This is an abstract method. You can also call it, say, move. So why did I rename it to determine next step? See, now there are different strategies or different algorithms that are possible, correct? What are the different algorithms that are possible? Let me just write them down. So suppose there is one look algo control strategy. There is one scan algo control strategy. There is one shortest seek time, the SSTF. Let me just write SSTF. Shortest seek time control strategy, right? So control strategy. Then there is FCFS, first come, first serve. First come, first serve. Control strategy. Okay, so these are different control strategies. All of them are doing what? They are determining the next step. So whatever request will come, no, all of the requests will come to these guys. One of these guys, essentially. Basically, it will come to elevator control strategy. Now, this strategy will determine the next stop. Where do you have to stop next? Like first come, first serve will do what? It will store all of the requests in a queue. This guy will do what? It will store all of the requests, say, in a heap. This guy will say store it in a stack. Maybe this also stores it in a stack. Whatever request is coming, it will give to this strategy, and the strategy will decide for us that what is the next step. And the controller will stop accordingly. So the controller basically has a strategy, and the strategy obviously cannot exist without the controller. So the controller has a strategy, and the strategy is telling that this is your next stop. That is how I've designed it. Does it make sense?
Hello, Kirti. Actually, these are the algorithms, right? And you, in the main function, you have mentioned set algorithm.
So there are two algorithms. We had talked about that. So one algorithm was movement of the algo, right? Movement of the algo. There was another algorithm which was key selection of the elevator, that out of 4, what elevator is going to come, right? So in the main, I was basically setting what algo? I was setting the elevator selection algo. The elevator selection algo. Here, because the movement is taken care by the controller, and maybe I want every elevator to have a different algo, right? So I have an elevator control strategy, and that I am deciding over here. Maybe you can design, see, I'm not saying this is the way to go about it. What you could have done it, you could have probably set it over here only in the main. And you could have told that, okay, whenever you create all the elevator controllers, this is the particular strategy that you have to use. How I have designed is that I am letting the controller decide that what strategy will be used. Make sense?
Understood. Yeah, thank you. Just one question. For designing a base system, we have to choose a best algorithm that will always satisfy our need, right? So why there are different algorithms are required in that case?
So in the requirements, I told you that I wanted to support different algorithms.
Okay, sorry.
Okay, so yes, you are correct that you might want only one algorithm. In that case, what will happen is, say you want to use this look algorithm. You are saying that this is the most effective one. So in that case, what you would do is you would not have strategy in these algorithms. Inside the controller itself, say there will be priority queue, and there will be stack or something like that. And then you are running the algorithm inside the controller. You can do that, but I have given you the requirements that I wanted to support different algorithms, and that is why we are designing like this. Make sense?
Yes, yeah, fine.
So this selection of algorithm will be done only one time, right? In the starting only. It won't be will be done in runtime on the fly.
So it will be done one time, like only in the starting.
Okay.
But the system can be used in many buildings, in many elevators. So for every elevator, you can decide that, okay, this is the strategy that you want to use.
So admin will have the right to do it the first time, right?
You can set it, yes.
Okay.
Sorry, I could not get this. Only once we are setting the algorithm?
For every elevator, we will say that this is the algorithm that you always have to use. So if there are 20 people coming in requesting, same algorithm will be used for that elevator, right? Suppose I am in one building, I'm in building A. One particular elevator is using this algorithm. In another building, suppose another elevator is using another algorithm. Always that algorithm will be used. Now admin can set it, or we can set it once that, okay, this algorithm should be used. We can obviously change it also, but it doesn't make sense to change algorithm on the fly, right? Always.
But strategy pattern is used when there is a dynamic at the runtime we have to choose.
You can think of it like this. So yes, valid point. You can think of it like this. Why I've done like this is that there can be different systems. See, elevator system being used in different buildings. Now, based on some input, my admin is setting. So runtime is happening by admin, but it is going to happen only once in a while. It is not that with every request it is changing. We can decide runtime. We can decide the strategy runtime. Admin can set it, but it is not like with every request that the customer is sending, I am changing the algorithm. Does it make sense?
So one doubt here, can I ask? So wasn't it better to include the strategy in the elevator itself? Then it would have become a part of a builder design pattern. So the intent was clear, right? That elevators are same, but the configuration is different. So builder design.
You could have done that. But if you think of what my thought process was, that elevator already has a lot of things going on, and I want to abstract out the movement part, right? So that is why I have a movement controller. Right now, movement controller seems like this, but in reality, it will be connected to hardware, right? And it will be actually doing this. And here, there are already a lot of hardware that will be there, like displays, there's door, there's capacity, there's light, there are a lot of things that are happening.
So we can go both of these, right?
Yep. Like that you can do, but I wanted to keep the classes smaller and I wanted to abstract it. That is why I've done it like this. Okay.
So Kirti, basically, yeah, go ahead.
Yeah, go ahead, brother.
Yeah. So recently I had a chance to apply this strategy pattern with respect to retrials actually. So there was different variations as to sync, async, linear, exponential backoff, and for different types of requests, HTTP, non-HTTP, and so on. So what I found is that it's not more about compile time or runtime optimization. It's a code optimization where you write code in such a way that it can be reused for multiple different purposes. Am I being close to what the strategy pattern is, or like it's meant for something else?
See, when you want to have different algorithms for achieving the same thing, that is the crux. Now, obviously, you do achieve reusability, you do achieve maintainability, extensibility, all of that. What is the main thing? You want to use different algorithms.
Yeah, so it has nothing to do with polymorphism of sorts, right? Runtime optimization or something like that.
There is runtime optimization because you can decide the algorithm runtime. You can do that. But the point is that you want to decide that, okay, what algorithm you want to use when. Over here, I am using, say, look algorithm or scan algorithm or this algorithm or this algorithm. My admin can set it, right? So that is sort of runtime. I am giving that extensibility that you can set the algorithm runtime.
You can say like one way it is saying that you have the option to choose it runtime, but it doesn't specify how often you will that runtime will run. It can be once a year or once every request. So that's up to you.
Yep.
Yeah, use case could be suppose you have chosen one algorithm by admin, and if you see that electricity bill is coming a lot because of this algorithm, you might decide to change the algorithm to see if the electricity bill will be lesser if you use this algorithm. That might be effective. So admin can switch it to different algorithm.
Yes. See, because in elevator, if you think about it, the best thing that we want to do is save up our electricity. If we use, say, one algorithm and it is going up and down, up and down, up and down again and again in scan, doesn't make sense. So you optimize it and you say that I will use look algorithm. I'll come down from when I need to, and I will go only till here like that. So you are saving up on electricity. So basically your admin can decide based on some factors that I want to switch the algorithm.
Got it.
Well,
I think
we don't talk about runtime optimizations when you're talking about LLD, right?
You have to make a system extensible, right?
Extensibility is not runtime optimization, no? Extensible would mean runtime optimization is basically my code is running faster than it would have if I would have implemented it in some other code.
Yeah, so it's not a runtime optimization. We are basically trying to make it more extensible.
Yep, that's the right.
Correct.
I mean, that's what I meant by code optimization. So yeah.
Cool. Okay, I guess we are really debating. Guys, come back. I have to also show the code. It is already 10. I guess this much is clear, I think, more or less. I'll show you the proper UML and the code as well. So elevator has elevator state, elevator has elevator controller. This is the one that is taking care of the movement. And then there are different strategies or different algorithms for the movement. This much is clear, I think. Yes. Can I get yes in the chat? Please, everyone awake? Everyone awake? Yep. Okay, thank you. Now, we said that there is one elevator system. The question that came in between was that firstly, where is this request going? There's internal request, there's external request. Who is fulfilling these requests? That was one question. Second question was that there are many elevators, right? Like there are 4 elevators. So where are we storing like, that there's a list of elevators or there are these many elevators. Do we do that inside the elevator system only? Now that is my question. Let me know the chat. Do you think that this list of elevators, should it be there in the elevator system itself?
No.
Okay, I can see a lot of people saying no in the chat also. What is the reason? Why should it not be? Yeah.
Yeah, elevator system is something that is, I mean, our client is directly talking to elevator system, right? So we don't want the client to know the internal details about how many objects.
How we are doing it, what we are doing it. It is like a facade that is outside. We want to separate out the implementation on that. Yes. So that is why what I did was I created another elevator manager. Just listen to me. See, don't get worried about the jargons and everything for those who are doing it for the first time. What right now I'm doing is I am managing all the elevators together. That is why I called it elevator manager. Okay. What is there inside this? Very simple. There is a map. Basically, there is which corresponds to elevator ID, which can be string or integer. Let me just write it like this. So there is elevator ID and there's the actual elevator ka object. So basically, whenever I need the elevator ka object, I will go to this manager, say that this is the ID. Can you please get me the elevator? So there will be like a method inside this that get elevator. And I will pass the ID and I will get what? I will get the elevator object. Make sense? Raj is saying, please repeat this part. So I'm saying it again. See, elevator system is what? It is the one that my client is talking to. Correct? So my client is talking to the elevator system. I also want to manage all my elevators in one place. Suppose there are, say, 4 elevators. So here I said initialize, but what is happening inside this initialize is that I'm actually initializing this elevator manager. And this elevator manager is the one that is creating these 4 elevators, 10 elevators. So basically my system is, I will get, say, admin will say, initialize the system. It will say that, okay, there are these many floors, there are these many elevators, something like that. And then the elevator manager will actually say, create the IDs, create a map that this is the ID, this is the elevator object. So this is the manager. It has the information of all the elevators. So whenever you have the elevator ID and you want to access the elevator object, you're going to come to this manager and say that for this ID, please give me the elevator. Does that make sense? Any questions?
And where would be adding in this class only? Client will be adding the elevators in this map ID.
So why will client add the elevators? First of all, we as a system,
admin.
Yeah. So right now we have not designed for admin. In the starting, we said we are designing for customer. So for now, I've just in my main, I've in this initialize itself, I've just given to elevator manager, and elevator manager is the one who's creating it. But ideally, if you were say designing for your admin also, your admin would come and say create elevator manager or create the elevators or update the elevator status and things like that.
One short question. Are we keeping the objects here, like ID versus the objects?
Yes, the object, yes.
So why don't we do a load and runtime? Because on a single request, I would need only a single object, right? So why do I need to keep state of 4 or 5 objects?
So how will you know that?
Need all objects.
How will you come to know that what object you have to return?
So I already, okay, I have the ID, right?
But where
basically
what
ID is the primary.
Okay.
Think of it like a not to confuse you, but like think of it like a database. Many people think of it like this. that you have to have the object somewhere. No, where is it? Where is the elevator object flying around?
Yeah, got it. So in my design, I kept the application layer and manager different.
Okay. So now, what will be the relationship between elevator manager and elevator, guys? Chat, come on, tell me. Someone is saying one to many. Yes, so multiplicity will be there. But what kind of relationship has a okay, now aggregation or composition? Aggregation, composition. People are saying aggregation. I have done composition. Why? Because I don't want my elevator to exist without my elevator manager. Now you can say that my elevator can exist without the manager. Maybe it is in some other building. I don't want like that. I have designed my system that my elevator should not exist without my elevator manager. That is like the topmost layer. System has manager. So again, my system has manager. Again, the composition relationship over here. So basically, elevator system, we are doing the first system today. I've kept it very simple. So there is no multi-threading also in elevator system, correct? And there is very simple. So basically, my elevator manager cannot exist without elevator system. Elevator cannot exist without elevator manager. Composition. Simple system we are designing right now. Not very simple also, but yeah, good system. Yeah.
Kirti, just one question. Can you please repeat why did you take a map and not a list?
I can keep a map. I can keep a list also, but a very common request that I will get it that this is the ID. Give me the elevator object. Right? So it is better to keep a map.
Okay. Otherwise, you would have to search by the list.
Yeah.
Okay.
Also, Kirti, one question. This elevator manager will be interacting only with the elevator system or with our client also? Will our client also have access to?
Client will have no idea. So client will talk only to elevator system. So this is the facade. This is the upper layer. So if I am the customer, I can only see elevator system. I cannot see elevator manager. I don't even have access to the elevator class. I am telling the system.
Okay.
Yes.
Okay, see, this elevator system is for a particular building, is it?
Yes.
Okay. And when does the entry get added into this map? When the elevator is coming up?
In the initialize, when I set up my system, that is when I've actually added the elevators.
Okay.
Ideally, admin should be adding it, but as I mentioned in the requirements, we are not doing from the admin perspective. We are doing only for our customers. So that is why I've not done that part. Right now in initializing, I'm just creating the elevator manager. And I am creating elevators over there. Another very good point. So we already talked about elevator system being singleton, correct? Single instance. I have kept my elevator manager also as singleton. I want one instance of the class managing all my elevators. Does it make sense in a particular building?
But what if you have various type of elevators? We didn't discuss service lifts or passenger lifts or something like that, right?
Good point. See, when I was designing, I actually thought about it. So we could probably use, while creating of elevator, we could use factory design pattern because there can be different types of lifts, right? Like there can be service elevator, there can be a passenger elevator, and there can be different kinds of elevator, right? They can be, say, a private elevator. But what I thought was that it would be an overkill to use factory because what is different in these elevators? Only, say, the capacity. Rest, everything is going to be the same. Display is going to be the same. Buttons are going to be the same. Control movement is going to be the same. Correct?
State would be different now.
Sorry, what?
Your state, elevator state would be different, right?
State is going to be different for every single elevator, right? So
No. So when I say state is going to be different, I mean the access state. So you won't allow certain people to go in private elevator, or you won't allow private elevator to go to certain floors, something like that.
Does
right?
my elevator system actually control it? So
Yes, so your manager should be controlling that, no?
Okay, so as a software, okay, what are we designing? We are designing the software of the elevator system. If there is a sensor that, okay, there's a human being or there's not a human being, we can talk about it. But unless there is a hardware sensor which detects that, okay, this is a human being, this is not a human being, I will let this thing or this guy pass into this elevator or not. Will we, as a software, will we come to know?
No.
Right? So I at least did not take that part, that there is a sensor who is detecting, okay, is this a human being or not?
Okay, perfect.
Yes. Yep. So for me, everything else was same. So in elevator, I could just keep a type, like a member, say type, that this is this service or passenger or private or things like that. If you were talking about private, now it would have been a good point that in private, you could have said that my, the control strategy is going to be different. Like what happens in private elevators is that suppose we are in a building and suppose Shah Rukh Khan also stays in the same building, SRK. And this guy stays at, says, this floor, 13th floor, right? So this particular private lift will only go from 1st to 13. Maybe there is, say there is a check that if I say that I want to go on 5th floor, it will reject it. It will say that I go only to the 13th floor. I will not go anywhere else. It is a private elevator. In that case, you could think of it and all of that is there. But for now, I am just ignoring all of these cases. I have to draw the line somewhere. And right now, you can just keep a type inside the elevator. If the creation process would have been different, then I would have used factory. Right now, it seemed like an overkill to me. That is why I did not do it. Make sense? Yes?
Yep.
Yep. Okay. Cool. Okay. I talked about elevator system. There is elevator manager. Now just last thing, and then I will show you the code. Okay. Just last thing that I wanted to, I will show you the proper UML that I've drawn and proper code also. By the way, the UML, the code, everything is up on GitHub. So you can check out over there itself. Okay. Now the question, the last question that is remaining, the most important part, that this send internal request and send external request, once it comes to the system, where is it going from here? Which class is getting hit from here? What class do you think?
Elevator movement controller.
I'd rather have an application class that would classify between internal and external requests and point it to the required classes.
Let's also think about what is going to happen. Like whoever calls this, what all things have to happen? Say if it is an external request, if there's a source floor and there's a destination floor, or say this one, let's take the simpler one, this one. I have a direction and I have a source floor. I do not have a destination floor. First, I have to select which elevator is going to come, right? So in my external request, so if I have external request, there are two things that I have to do. Firstly, I have to select the elevator, that which one is going to come. Then that elevator I have to tell that, okay, you start moving. See, until I have this elevator, I cannot really tell that, okay, that who is the controller, correct? Because the controller belongs to a particular elevator. So who is going to actually fulfill this external request? And the internal request, what am I doing? So I'm already inside the elevator. This you could say, sort of give it directly to the controller. But then what would happen is that my system also has access to the controller, which I don't want. So my system has manager, my manager has elevators. Correct? So I have added one extra layering, one extra abstraction sort of, and I have added request processors. Where can I add it? I will show you a better diagram. Sorry, it has become very hodgepodge. So I've added request processors. Now you could either have one request processor or you could have multiple request processors. So I have added two request processors, external and internal. And we can talk about, okay, do we need two? Can we have one? But for now, what happens is that these that send internal request will go to internal request processor. Send external request will go to external request processor. Now this guy will go to elevator manager and talk. Now let me show you the UML and actually show you the workflow. Excited? Yes? Yep. I guess more or less you have understood. Let me show you the proper UML and the code and let's get to understanding all of that in detail.
Kirti, why we have added an indirection of this request processor? What purpose is it solving?
So the requests are being handled by request processor. I've basically tried to follow SRP as much as possible. Why SRP? See, basically, my manager is responsible for what? My manager is responsible to have all the elevators. My request processor is doing what? Yes, Vasant is saying loose coupling. So everything has a particular need. Yes?
Yeah, we'll see in the code. How is it going to bring more value? Are we looking at like it will be an interface, like request processor will be an interface, and then again have multiple implementations.
Yes. Yeah, you should be able to add multiple implementations. So yes, let me just show.
One more additions to this. See, normally when we do requirements, we bifurcate into masters and transaction and reports. So we start with the use case, that what is user requirement is, and then we go to this like the masters, like how. So let's say when you say elevator needs to be constructed, and you said that they have different parameters, right? Members, right? What you call members, right? So that those all go into a master. So we're not talking about how will I define my elevator creation in this. We are talking about how the flow will happen. How will the interaction of user to a system will happen?
As a software, not the hardware thing, yeah.
Not as hard, but just like when you said map ID creation, like ID and elevator, right? So that means somewhere in database I need to maintain that elevators, right? Multiple elevators with an ID, and then their corresponding. When you have an elevator, then you are defining the characteristics of an elevator. Somewhere they are going to get stored into a database. For that also, I need to have first interaction of the admin user, as you said that we are.
See, firstly, for a system like elevator system, I'm not even sure whether you need a proper database because we don't have anything offline.
Yeah,
right? A local database is good enough.
Okay.
Sorry.
The objects will be in memory, I think.
Yes.
No need of data.
But just to answer your question, right, the creation of DBM, storing it anywhere. So we are talking about the customer use case as of now. We're not talking about the admin use case. If we were talking about the admin use case, then I think we would have talked about how our elevators are being created, because then admin has the authority to, decide the capacity and all that stuff.
Okay. See, that's the reason that when we are saying that when we're creating system or manager or all of them appears to be singleton, because we are using it for one elevator, right? One object we are using.
See, one system. So one system for different buildings, but it can be reused, right? Like for different systems. So yes.
Okay. Fine. Thank you.
Okay, cool. Everyone, full focus. Now I'm going to show you the proper UML and the code. Can I get more awake? Yes, on the chat. So I can see that everyone is able to see properly. Yep. Going good so far? Okay. So this is the elevator system. This is where the request comes. Here you can see that there is a minus in front of the constructor. Why is this minus? Why is this
Singleton pattern?
Private constructor. Very good. So this is private constructor. So see, again, back to basics. From the UML itself, you should be able to tell that what design patterns you're using, what are the relationships between the classes. By the way, in my UML, I have not mentioned the getters and setters because honestly, I was very lazy. Getters, setters is like too much effort. Just getters, setters, I have not added it. Rest, everything I have added. So here you can see elevator system. I made the constructor as private. It's minus. Here you can see there's something underlined. What does this underline mean?
Static.
Yes. So you can see there is a static instance, which is private. And there's a getter, right? Get elevator system. It is going to return the static instance, right? I have written I've added pointers because for C++ people, for Java people, just ignore all of these stars. Just ignore the stars. That's it. Rest everything is same. Okay, I've written the code in both C++ and Java, so don't worry about it. In the starting, there's just initialize elevator system. There is set elevator selection strategy, that what strategy are we going to use to select. This is again an interface. We'll talk about it. Send external request and internal request. In external request, what am I sending? I'm sending the direction and the source flow. I've written it in caps because it's a enum, basically. That is why it's in caps. There's one send internal request. There's one send external request and internal request. Let's quickly see the manager in the elevator, and then we will see one request flow. Okay. So let me also show you the code of elevator system so that, we can go ahead as we talk about it. So elevator, let me just close everything else. So here you can see the elevator system, correct? So there is a static instance, number of floors, number of elevators, all of that is there. There is external processor, there is internal processor. There is a static getter, and then there are some methods. Initialize, send external request, send internal request, all of this. Yes. Similarly, I've written the entire thing in Java also. So a lot of effort has gone behind it. But yep. Okay. Where is my elevator system? There's my elevator system. Here you can see there's elevator system. There's a static class. There is basically request processor, external, internal. There's the static getter. Why have I not taken care of double check locking, or I've not followed all of that? Why have I not done that?
No multi-threading.
No multi-threading, right? So here also, if you see the C++ code, you will not say I've not done double check locking. This is not a multi-threading code. Okay, cool. Now, elevator system has elevator manager. What does this have? It has a map of elevator ID and elevator, the object. Okay, this is again singleton. So there is a static instance. There is a static getter, and then there is initialize elevators. Let's look at the code. So if you look at the elevator, so from here itself we can go, right? So there's the elevator manager. Here we can see in the initialize elevator system, what am I doing? I'm initializing this getter, the static getter. I'm actually initializing it. And let's see what's happening inside this. So here, basically, simple thing that I'm doing for now, that for these elevators, I'm just creating new elevators. This is for demo purposes, right? So I'm just creating the object over here. If you see the HPP file of this, so here you can see, right, that there is one instance. So in this manager, again, this is static. There is a map. This is this, and then get elevator, initialize elevators. Simple thing. Okay, cool. Let me also show you the Java code. So elevator manager. So if the Java code is open.
Hi, Kirti. Can you please debug so we can visualize it properly?
Let me first show you the entire code, because if I start debugging, I'm sure a lot of people will get lost. And I'm not talking about the flow right now. I'm talking about the classes, right? So let me first show that. There's elevator manager. Inside this, there is map. And then there's get elevator. And then there's initialize. Simple thing. This is just the starting. So let me first show you the main. Let me show you the main from where the things are starting. So you will get some idea about that. So this is my main. Here, what did I do? I got the elevator system, get elevator system. I initialized it, say for 12 floors and 4 elevators. I can change this runtime. I can set the elevator selection strategy. Right now I'm using odd even. I can use this zonal one or any strategy that I want. Here I'm setting. And then here I'm sending the external and internal request. Everything, my client is talking only to the elevator system. It has no idea about anything else. In external request, I'm saying I want to go down from this floor, or in internal request, it is saying that I want to go to this floor and I am in this elevator. That is it. In Java also, same thing I am doing. Does it make sense? Here you can see what am I doing. So there's a system. In the system, what am I doing? I am setting the elevator strategy, and then I'm saying send external request and internal request. Let me run this and show you if you want to do that. See, so suppose Java code is running right now. Oh, so I actually just ran it. So you can see it over here, right? Initializing elevator system with 12 floors and 4 elevators. So now selecting elevator according to odd even strategy. Algorithm, I've used some algorithm and I'm moving the elevator. Here also I'm doing this. See, if you want to see how the strategy is changing, like for now, I am going to source floor 10, right? If I go to source floor 9, what is going to happen is that instead of elevator ID 2, it should use elevator ID 1. So in my odd even algorithm, what I've done is that if it is even, use elevator 2. If it is odd, use elevator 1. Right now, I've just done a simple thing. So let's actually run it and see. So here you can see ID 1. So same thing will work. So whatever, if I change this, basically source floor, if I keep it to 11, again, it should give me 1. It should give me 1. But suppose if I keep it, say 6, it should give me 2. So basically, I am using a particular algorithm inside, right? And I can change it. See, for 6, it is giving me elevator ID 2. And I can change the strategy also. So depending on zone. So if it is, I can add a zonal strategy also, that if it is between this to this source floor, then use this elevator ID or use this elevator ID. So everything is happening inside. I have no idea. As a customer, I just know that there's an elevator system and I am doing the entire thing. Make sense? Can I get yes?
Kirti, seem like line number 4 we have singleton, and line number like 11 we have strategy pattern. And what we are using in 11th, line number 11, which pattern we are using here?
Okay, come down. I will show you. There are request processes and all of that. Basically, there is a facade. There is one elevator system where we are sending the request, right? Because you wanted to see the outer thing, I've showed you. But how the request will be handled, this request processor is there, external request processor, internal request processor. This guy, elevator system, is taking care of the entire thing. So if I go into elevator system, let's go inside this. So there is an initialize elevator system. There is set elevator selection strategy. Then there is send external request and send internal request. All it is doing is it is telling the external request processor and internal request processor that process it. The actual system is not doing anything. The elevator system is just a facade. Who is doing it? Inside the external request processor or the internal request processor. So depending on the request that is coming. Cool? Okay, it will become clearer. Relax. There is an elevator manager. There is a map of ID and elevators. This we just saw the code, but let me just show you again. So there is one elevator manager, right? If we go inside this, there's a map, the elevator ID and elevator. Right now I've kept the ID as integer. You can keep it as a string, however you want. Okay. There's a static getter. There's initialize, and this I'm just creating the elevators. There's a get elevator. Correspond like this for this ID, just give me the elevator. Right? Similarly for C++ code also, if you look at this, there's this, and then in the HPP, I think I've written the getter. Yes, that get elevator, that for this elevator ID, just give me the elevator. Cool? Yep. Yes, no, chat.
Ma'am, but doing this so much in 1 hour in an interview, it's not possible, right? Building this kind of UML and now having this kind of code. So like in an interview perspective, like how the interview gonna expect everything? Like
interviewer will not expect you to do everything. This is like a small mini project itself, as one of you already said in the chat. See, interviewer I will give you tips that how much to do, what to do, because I am teaching right now, right? So I have done a very extensive thing. Obviously, interviewer doesn't expect you to do the entire thing. Interviewer will probably expect you to do, say, this much. Elevator, like elevator controller, elevator state, maybe only this much. And how long has it been? It has been 1.5 hours. And we are discussing and answering questions, correct? You will be surprised when you actually start writing the code. You will be able to do this. You don't have to make such a detailed UML. You remember how I used to make UML in the class, like that I will just draw a box, I will just write the name and I will say, okay, these will be the common things. Like that, the interviewer is going to expect. The interviewer is not going to expect to show the entire details. Can you all see the code, by the way? Can you all see the UML?
External and internal में आप like कैसे differentiate करेंगे? Like how we
I will come to that. Let's just first see this because we already understood this properly, right? So let me just show you the code. Then I will talk about this also a bit. Okay, cool. You can see the UML, right?
Yes.
Okay, cool. So elevator has elevator controller and elevator controller has elevator state. State is what? Current direction, current status, current floor. Elevator controller has what? It has the control strategy. This is the interface. This is the strategy interface. Then there are different strategies. Someone is asking what is sensor class. Ignore it for now. I've just added to explain something extra that I will cover later. But for now, let's understand the main things. This part I think is clear now, that elevator has elevator controller has elevator state. Then there's elevator control strategy. There can be multiple strategies. Yes? Can I get more yes, guys? There's only one yes from Shimangi, I can see. Paras, Rekha. Okay, more yes, please. Okay.
Yes. So elevator control strategy is where you keep track of all the destination flows that you have to go to and where all the requests are stored.
Yes. Yes. So this guy will probably keep it in a queue. This guy will probably keep it in a heap. This will probably keep it in a stack. You do whatever you want. In the end, I want one integer. So I've renamed it in the code from move elevator to get the next stop. I'm not renamed it in the diagram. I will do that. So basically, to avoid the confusion, it will return basically an integer. What is my next stop? So this will run the algorithm and give me the next stop. How you're doing it internally is your problem, the algorithm's problem. Okay. Now let's see.
One more. Till date, we are using all behavioral pattern and we saw creational, but like none of the structural came into picture.
What are the common structural design patterns that we discussed?
Your composite, your bridge pattern.
We covered facade, right?
Yep.
Facade, was it?
External, the system is the facade, right? See,
okay.
Don't force fit the system, the design patterns. Again, what are you trying to solve? Are you following the solid principles? That is the most important point. What is design pattern for? To solve your problems, right? If there is some commonly occurring problem, we can solve it. I've actually added sensor because I wanted to show you that we can use observer design pattern, all of that also. But for now, I don't want to overkill anything. Let me first show you one request ka entire flow, then we'll discuss that. Yes?
Okay.
Yep. Okay. So there are two kinds of requests that are coming. We already talked about this. There is one external request, there is one internal request, correct? So I have created two processors. You can argue with me. You can say that there should be one request processor. And inside this request processor, you can have external request and internal request, or you can have like a base class and then there will be derived classes. You can argue with me. There are different ways to code, but let me explain why I've done this and how I've done it, and then we'll come to that. Okay. See, in internal request processor, so it is very simple. What happens in the internal request? Let's look at the code. So if we look at the demo, right? If we look at the demo, this is where I'm sending my internal request. Now, what happens that I just say that I am inside this elevator and I want to go to this particular floor, correct? So I'm already inside the elevator, so I don't have to determine the elevator. Correct? I just have a destination floor and I have to just go to that. Yes? Everyone understands that? Yep. So now when I send this, so I am basically telling my internal request processor that you process it. Now I have created two different classes also, internal request and external request. Why have I done this? See, currently in my external request, and let's see what is there in my internal request and external request, okay? Currently in my internal request, there is destination floor and there is source elevator ID, like in which elevator am I and what is my destination floor. Similarly, there is one external request also. What is there in external request? There is which direction I want to go to, and then there is source floor. As one of you like already told that there can be say another requirement that in my external request, I already give the destination floor. Or probably, you know, something else I want to pass with the external request, maybe what is the current capacity, and based on that I want to decide my algorithm or do something like that, right? So I want to keep my classes as extendable as possible. That is why what have I done? I've created different classes, external request and internal request. Make sense? Yes, no? Yep, okay. So external request basically simple. It has two things, source floor and direction to go, and then it has getters and setters. And then there is internal request, there is destination flow, there is which elevator am I in, it has the ID of that. So source elevator ID, in which elevator I am right now, the ID of that elevator and the destination flow. Okay, so it has these two things, and then there is setter and getter, correct? coming back to my demo. So elevator demo. So I am over here. When I say send internal request, I go to my internal request processor and say keep process internal request. Inside this, I have passed internal request. What is there inside this internal request? There is destination floor and there is source elevator ID. I could have passed these two things also. As I said, I'm just keeping it what? I'm keeping it extensible. I could have passed the destination floor and the source elevator ID over here itself. I'm keeping it extensible. I should not have to change it again and again. If I want to add something, I can just add it in the internal request itself. I won't have to change the methods everywhere. I won't have to add new methods, right? Correct? And that is why I'm doing this. Now here, what am I doing? I'm from this elevator manager. So this is basically singleton, right? So I get the elevator manager and I say that I have the elevator ID, right? In the request. So I am just getting the elevator from that, the source elevator, and I'm telling the elevator that you move to the floor. Does this sound okay? What am I doing? Let's look at the diagram. So if we look at the diagram, the elevator system send the request to internal request processor. The internal request processor has internal request. What is there in internal request? It has the source elevator ID and the destination floor. Because it already has the elevator ID, it has the elevator ID, it goes to the elevator manager, this, so it accesses it. That is by unidirectional association. So internal request processor can access the elevator manager. It cannot happen the other side. That is why unidirectional association. My internal request processor goes to the
seems like internal request processor जो है वो मतलब elevator के अंदर से press कर रहा है. That's why they are internal.
No. Internal request processor means you are the customer is inside the elevator and making the request. External request.
The person it's in the lift or elevator, we can say.
Yes, the person is inside the lift. Because the person is inside the lift, you already know the lift ka ID, the elevator ka ID.
So external means floor से हम press कर रहे हैं.
From outside we are pressing. So in that case, we do not know which is the lift that is going to come. So we have to determine, our system has to determine that which lift will come.
Okay.
Correct? Yes? Okay. So my system meant to the internal request processor that you process this request. It already knows that in which elevator I am, right? Because I am inside there. So it goes to the elevator manager. It says that this is the elevator ID. You give me the object, the elevator ka object. Then it goes to the elevator ka object and it says that you start moving in the direction the request has come. You take the request, right? Who is taking the movement ka request? The elevator controller. Correct?
One doubt here. So why is it having the access to elevator class unidirectional when it is getting the object straight away?
See, so I am inside the elevator. Yes. I could have had elevator ka object. Yes. But the request processor, when you send the request, you are basically going to send, you're not going to send the entire elevator ka object, correct? You're going to send an ID that this elevator ID is requesting for this. Like in real scenario, if you think of it, are you going to pass the object everywhere? To identify the object, you're going to pass an ID, correct? That this is the elevator, the inside which I am.
So yeah, that's my doubt is the internal request processor is already having the elevator ID. So if it wants to fetch anything, it will directly go to this elevator manager, right? Why it has the access to elevator class?
So, okay. So look at the code. So this is the internal request processor. It went to the manager, got the elevator. Went to the elevator manager, got the elevator, correct?
Yeah.
Get elevator manager and then get elevator. So this is the ID, get the elevator. Now, once it has the elevator, see, what is the responsibility of the elevator manager? It just has the map. It is not the elevator manager's responsibility to say that you start moving to that floor. Whose responsibility it is? So my request processor is telling the elevator that I am the one who is requesting the process, right? The internal request processor is the one who is processing the request. Elevator manager's responsibility is what? Just to keep the map. That if someone comes to me, asks me for the elevator object, I'm going to return it.
No. My doubt was like this internal request processor, right? It's already getting all the details of the elevator via elevator manager, right?
Hmm.
So then why is this relationship needed between internal request processor and the elevator class? Yeah,
How will it
highlighted
tell
that.
the elevator? So basically, it is telling the elevator, no, that you need to start moving. Where am I? I am inside the request processor. Once
Yeah.
I get the elevator, I need to tell the elevator that you need to move, right? So
But
I
it
am
doesn't
talking
have the access, right? It got the elevator object via the manager, right? So it doesn't
but it
has the
got the
access to.
object, no. So
So
it,
that also becomes the association.
yes, it has the access to the object, correct?
Okay. So okay, if not via class, but indirectly also it is having the access, then also it becomes the association example.
See, there are many objects of elevators. So to which object to go to, that is why it is going to elevator manager. And saying that which object should I go to? I don't know that. It has access to the elevator. But which object of the elevator should the request processor send the request to? For that, it is going to elevator manager.
Okay.
So it first went to elevator manager, got, okay, which is the object who is going to move? Then it told that object that you need to move. Which is that object? It is the object of elevator. I can access the elevator, but I don't know which object, right? So that is why I'm going to the elevator manager, getting the object.
But even if it doesn't has the access to the elevator class, then also it will be able to work it, right?
It obviously has access. That's why we are able to return the elevator, no?
So my doubt is is association an example of this also, that
Yes.
if you are able to access an object indirectly via some other class, then also it becomes
If you are
association.
able to access it, see, I am inside internal request processor. It is not via some other class. That class is returning me the object, correct? But there is an elevator inside this, right? You can access the elevator inside the request processor. Look at the code. I am able to call elevator from request processor, correct?
Yeah. Okay. Got it.
See, this is the request processor, process external request, right? So this is the external one. We are looking at the internal one. So let me show you the internal one also. So internal request processor. So here you can see process internal request. It is calling the elevator, right? It has the access to the elevator. Even if it is getting the object from somewhere else, it has elevator inside this, right? It is able to access it.
Basically,
Okay.
uses relationship.
Uses relationship.
Okay.
Cool. So internal request is clear to everyone.
Kirti, can you please show again how are we categorizing if this is an internal request or external request? Because I think the elevator will just receive like a request and then it has to categorize that, okay, was this an internal or external?
So I have kept it very simple. From my system itself, I am saying that this is an external or internal. Because external, what is happening is that there are two things I have to pass. That where am I, the source floor, and the direction in which I have to go. Then there is external request. In the internal request, I have the elevator ID and the floor. If you look at over here, the elevator. The Java one, you can actually see it properly. Here you can see the destination floor and the source elevator ID. Here you can see the direction and the source floor. So in the elevator system itself, there are two requests.
So right now we are manually basically calling the correct function, but in an actual elevator, we will just get the request and we have to basically decide that if this is an internal request, then call the send external request and internal request, so send internal request. Is it that?
Ideally, what is going to happen is that there is going to be hardware, right? There is a button outside and there's a button inside. If the outside button is being pressed, then the outer one will be called. If the internal button is being pressed, then there will be internal request.
Okay.
So actually, I started coding all of that also to show you, but I know that there will be no time. So I have a button, then there's press button. Then there will be external button and internal button. So there will be, I have not coded all of this because I knew I won't have the time.
Yeah,
But
we have a chain of responsibility here that basically selects the correct handler.
see, I think you're getting confused from why do we use chain of responsibility? What is the main problem that chain of responsibility solves?
I think one of the handlers needs to handle this, so it can just pass this
Yeah.
request.
You can like when you are doing chain of responsibility, beforehand, do you know the request which is coming, who is going to process it? Like in
No.
this case, then that's the responsibility of that's the case where you use chain of responsibility, where beforehand you don't know. But here beforehand you know, right, that which request processor is going to process your request. So why do you need chain of responsibility?
Okay, so I got your point. So I know at the exact handler.
Yes.
Okay, got it.
You
Thanks.
know that if this button is being pressed, it is an external request. If the button is being pressed from inside, it is an internal request. Correct? And inside this elevator system itself, so if you can see over here, inside this itself, I have these senders that, okay, send elevator, send external request and send internal request. In the external one, I am sending the request to the external request processor. In the internal one, I am sending it to the internal request processor.
Got it.
Yes?
Kirti, I have a question. Where is the elevator ID obtained that we send to the internal?
So for now, I have just kept it very simple. So in my elevator system, if you see there's a manager, right? Let me just show you where's my elevator manager. No. If you go inside this, when I'm initializing this, for now, I've just kept it that 1, 2, 3, 4 like that. I've kept it. Like ideally, it should be generated somehow. For now, I've just kept it 1, 2, 3, 4 inside the initialize elevators.
Okay, I
Kirti,
was asking I was asking for the internal elevator processor, right? We'll send the ID of the selected elevator. Where is that selected?
See, when my user is going to come inside a particular elevator and press it, the hardware is going to detect that the button is in which elevator ID, correct? I am inside which elevator right now. See, we are designing what? We are designing the software system. So you have to understand that what is this request that is going to come to us. Because the button is in a particular elevator, we already know that what is the elevator ID.
Okay.
Yes.
Okay, I was thinking the external request will maybe give that.
See,
after deciding.
Hardware, the button is going to say that, okay, when this button is pressed, this is happening. Now, when the button is being pressed, we know that it is inside which elevator, right?
Okay.
So you can say that you have the elevator ID. Yep. Okay.
Sure. Thanks.
All right. So everyone has understood the internal request processing, how that is happening. Can I get?
Kirti, can you please explain some direction, like direction कैसे चल रहा है पूरा? Like हम press कर रहे हैं, ऊपर जा रहे हैं, तो वहां से कैसे किस move पे वापस आ रहा है? वो पूरा.
So elevator system did what? It said it pressed. It said ki send internal request. I pressed the button. Button detected that, okay, I'm inside. It detected it. This is the elevator ID. And the button pressed, when I pressed the button, it detected the destination flow, correct? Yes?
Yes.
So I send the
Yes,
internal request. So I send the internal request to this internal request processor. Now my internal request processor said, okay, I have the elevator ID. So it went to the elevator manager, got the elevator object from them. Then it went to the elevator, said that you have to start moving. Like, you have got a request. This elevator said, okay, I have a controller for that. It said that, okay, I have to move to this floor number. Okay. Then there's a strategy. So this has a strategy. So now this strategy has, say, a queue or a list or a stack of requests. Suppose there are a lot of requests that are coming in. Suppose internal itself, there are 10 people. One pressed 1, one pressed 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. Okay. Suppose 10 requests came. So now all of the 10 requests came to the suppose same elevator, went to the same elevator controller. Now what is going to happen is that this first come first serve wala, suppose we were using this strategy and this guy is suppose storing it in a queue. So in the queue, like it will store something like this, that okay, 1, 2, 3, 4, 5 or whatever came first, right? Suppose the request to 7 came first, it will store it. right? It will store it. Then suppose the request to move to 8 came. Suppose the request to move to 1 came, then 2 came. So this guy will detect that where is the next that I have to go to. Then it will tell the elevator control that you have to move. Then this guy will say that, okay, this is my hardware, and it will start moving.
ओके गॉट इट. बट डायरेक्शन ऐसे है ना, जैसे मतलब 7 के बाद अगर 8 आ जाए तो ठीक है, अगर 7 के बाद नीचे जाना हो तो फिर डायरेक्शन चेंज नहीं करेगा, वो पहले ऊपर ही जाएगा.
So that depends on the strategy.
That depends on the algorithm, isn't it? Like which strategy you are
So yes, got it. But like it is also like a chain of responsibility, like that moment decide कर रहा है वो कि कैसे मतलब.
No. It is not chain of responsibility because you are not passing that same request to different algorithms to choose. You are using the same algorithm again and again.
No. Like responsibility once it will reach to 8th, right? So that moment it will get the responsibility that you will go to the 6th floor.
See, first, it is an algorithm. Okay, it is an algorithm. You have different floors. You have integers that these are the different floors, right? It is not different objects which are deciding that who is going to fulfill this request.
Okay.
So how is the design pattern coming into picture? What are we saying? That there are different floor numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now suppose you said, okay, it will first go up, then come down. So say it is a stack that, okay, we are keeping in the stack, or say a priority queue, correct? That whichever is the least height, we will put in a priority queue. Now this algorithm is just putting that floor number in that. We don't even have different objects. What do we have? We have just numbers, and we have to come up with an algorithm to decide where to stop next.
Okay.
Make sense?
Yes, it makes sense. But question is like algorithm तो मैम हम खुद ही बना रहे हैं ना, like algorithm तो
is inside this. So strategy is what? It is an algorithm. In LLD right now, we are not talking about the algorithm, how it is going to work. That is happening inside this. We are black boxing it.
Okay.
Yeah. We are just telling the controller that this is a new floor number that has come. This is a new request that has come. Now this guy will decide it, okay, where I have to go, and then it will go. Also, guys, these end-to-end system classes are going to be much longer. So I guess it will be at least 11:30 today. So please stay with me. I hope you're liking the discussion, right? I will try to finish by 11:15, 11:30. Okay. So the more we discuss, the more you will also get to learn.
Yes, so one more question.
Kirti, could you please show move floor code? Because I think you were directly calling from elevator to move floor. So where is controller in picture? Controller and controller strategy.
See, who is moving it is actually the hardware. Who is sending the request? The elevator controller is the one who is sending the request. But for now, can we try to finish the external request processor, because a lot of people are leaving. So let's try to finish the external request processor, and then we'll come back to that. Yes? Okay. So there is one internal request processor. Then there is external request processor. Okay. So external request processor means that the customer, I am standing outside, and I press that I want to go up or go down. Correct? Yes? Guys?
Yep.
So what is there in the external request? So if I say send external request, so here you can see in the external request processor, okay, if I go inside this external request processor, I go inside this, there is an external request that I am sending, correct? External request in the process external request. What is there inside this? There is just direction to go and the source floor. Where was I standing and where did I press? Up or down? Make sense? Where am I standing, the source floor, and where do I want to go, up or down? Currently, I have wrapped it in a class. So there is external request class. Otherwise, what you could have done is that you could have actually just, you could have just passed it as two parameters, the direction and the source floor. I've just wrapped it in a class. Why do we do this? So tomorrow, if I want to pass another thing, I will just add it to the external request. Extensible, maintainable. Yep. Okay, cool. So in the external request, how is it different from the internal request? In the internal request, what was I doing? I was inside and I was pressing the exact destination floor. In the external request, what am I doing? I am saying that I just want to go in a direction. This is the source floor, right? So now I have to choose which elevator is going to come. Which elevator will come? So if there are 5 elevators, out of the 5 elevators, which will come and stop at the source floor, I have to decide. Yes. So again, so that you don't get confused, there are 2 types of strategies that we are doing in our system. One strategy is to select which elevator will come. And one strategy is to see that how is the elevator fulfilling the request. So if there are 10 requests coming in, which algorithm are we using to fulfill the request? This strategy that I'm talking about is the elevator selection strategy. So if I have 5 elevators, which elevator will come and stop? That is elevator selection strategy. Make sense? Yeah.
Kirti, the strategy will give us the ID or the elevator?
So this is giving us the ID. So here you can see, so if you see at the strategy over here also, so I pass the external request, process external request, this one, sorry. So select elevator and it is returning me integer. So elevator ID. Elevator selection strategy. Why have I written it in italic and like this? Why is that?
Interface.
Interface, that's why.
So basically these strategies will be forced to implement the select elevator. Yes. I guess now basics are clear, right? You are able to understand. Very good. Okay. So there is one basically. So this strategy has select elevator. So every strategy has to have select elevator. Yes. So in this, I am passing the external request. I am getting what? Elevator ID. So I am assigning the elevator. So now I have the elevator ID. This is the only extra step in the external request processor from the internal request processor. And that is why I said there could be one request processor. And from there, we could do the same thing. And we could have one extra step for external. That is one way of writing the code. For now, I wanted to keep it a bit simple because I thought that, you guys will really get confused 2 hours class. So for now, what I've done is that there is one, I have just assigned it. And again, I've done the same thing that I was doing in internal also. Let me just open it. So this is internal, sorry. So this is internal request processor. What are we doing? So in the internal request, there is already the ID. So first I get the elevator manager, I get the elevator, and then I say move to the floor. In the external, what am I doing? I'm first getting the elevator ID from the strategy. Then the same thing. These are the same things that I'm doing. I'm first getting the elevator manager, then I'm getting the assigned elevator, and then I am saying move to the floor. Make sense?
Yeah, one doubt here. Your internal request processor and external request processor, both are using your elevator manager, which is maintaining some its data structure map. And from that, we are getting final elevator object. So isn't it should be thread safe? Because both are independent requests which can come at the same time to the elevator manager, and we are getting the ID.
Yeah.
There will be delay of say a millisecond, microsecond. It will come one by one only. See, in the end, even if it comes at the same time, what is the problem that will happen?
So your data structure is not thread safe now. We are getting the ID. The data structure elevator manager, which is maintaining the map.
What is there in that data structure? Let's talk about it. So there is one ID and then there's the elevator object. Can the elevator object change? For now, what are we using that data structure for? We are just getting the elevator object from the ID.
Yes.
Even if they access it at the same time, what will go wrong? Are we creating new elevators on the fly?
Yeah. Are we adding new elevators also? Updating the new ones?
No.
Right?
We are just updating like the request only we are updating.
Okay, then it's fine. I thought like on the go, if new elevator comes, then we are adding also in our map, updating the map.
I feel that is like we are complicating the system too much because we are
Okay.
talking about elevator system design, right? How often
It's
will
not
we
even
add
real.
elevators that
So,
remove elevators?
yeah.
Okay, clear.
One question here, right? So our external and internal both request managers should have been async, right? So external request manager today will process an entire request and then only take up the next request, right? So how do I manage 10 or more people entering a lift or an elevator?
Okay.
Sorry, come again. What is the question?
So my question is, this system, what it is doing is, for example, I press that I want to go up, right?
Mhm.
So, and I have 4 lifts and which are on different floors. The nearest lift will come to my floor, right? And then in the internal, what am I doing is, when I press the internal command that I need to go on the first floor, as soon as I press it, that request will get processed. And once that request is processed, then only I'll take a second request, right? So for example, I pressed 3rd floor first, and then some other person came in and he pressed the first floor. His request will only be taken into account as and when my request has been completed, right? In case of an internal request.
No, it will depend on the strategy actually. So once you
Doesn't
press,
matter, right? Because strategy does not even know that there's a 3rd floor that has been accounted for yet, because it is still processing a single request, that is go to floor 1. Strategy won't matter here.
no, what do you mean by still processing? Once it
So
knows it has to move to the floor, other people can also like keep pressing. Like what is
how
stopping
does
it?
your system work, right? So system here, we do not have anything that's asynchronous. It's all synchronous. So for example, when I press a command, it will complete that command and then it will take up the second command. Think of the stack trace now.
I got your point. It's so I got your point. It's you are thinking the system is taking the request, processing it. You go to that floor and then only it will be able to take
Yeah,
up another
exactly.
request, right? But
Exactly.
yeah, it's not there. It might be not there in the code, but it will be like key. Once I get this floor to move to, it is good, and it will in the separate thread. Other controller is now working to send the motors to go to floor 3rd, and it is now ready to accept another request.
Yeah,
Getting it
but
right?
then
Like it,
But
but
it
then
will
the
again depend.
YAML will change, no, in that
But
case
it will
scenario.
again depend in which direction you are moving. Suppose you have pressed for 5th floor, starting from ground. Someone entered at the 1st floor. He want to go to the 3rd floor. So his request will be fulfilled first instead of yours, even though you had given the first request. It
Correct.
depends in which direction that another request is coming for.
Guys, when you actually use the elevator, haven't you noticed the one who presses first is the one whose request is first served?
No, so that service is not true, right? So if I press 1 and 7, then I'll go to the first floor and then I'll go to the 7th floor always.
Exactly. So you will first go. So how the
But
strategy is running, so you're just telling the number. And then who is actually going there is the controller who is talking to the hardware that you need to go there.
no, but
Correct?
my question here is not that, right? So my internal process will know, I mean, so it's logged. As soon as the request comes, my internal request processor is logged, right?
What are we actually doing inside that? See, we are just
Let's talk about internal process, right? So the internal
let's
one.
talk about the So what? Okay, let's say I make this async. Now, what will happen if I make this async? Is there some parallel processing that I need to do that as I take the request, I should be able to process it parallelly?
Yeah, right. You
Then
need to do that, right? So
why
for
do I
example,
need to do that? Yeah.
5 people board on ground floor, right? And all of them have to go to different floors. How do you know that there are 5 requests that came in?
So
If you're
5 requests
processing,
are going to come in. So elevator system is going to call 5 times that okay, send internal, and it will go to the elevator control. It will press it. So as the request come, the strategy will add it to say a queue or a stack, or as we talk, the strategy is going to be different. But why do you need to process it parallelly? You tell me this.
the reason I'm saying it is strategy is calling the move elevator, right? So if you see the code, we are calling move elevator, and
No.
the
So
output also says that
if we have
we're
started
moving.
moving the elevator, we cannot do it parallelly, right? Like once the elevator started moving in one direction, you cannot go like, oh, now it has started. What will happen after that? Once it has started moving, Now I think I have gotten the request. What will happen now?
So, see, the thing here is that let's take it this way, right? Let's draw a stack. Imagine a stack. 5 people vote on 7th floor and the lift is going downwards, right? And then the commands are like 6 or 5 4 ऐसा करके. But let's say सबसे पहले जो चढ़ा, he pressed the 4th button, right? Now internal process internal request object, that instance is logged because it is processing the 4th request and it won't stop. I mean, it won't get free until and unless that request is processed or it is it has a
Processed,
spot.
it just
No, why
gave
do you
it to
think
the-
it's logged?
Why? Like it just gave and just gave the strategy that okay, you add it over here, and then
So strategy, it is calling move elevator now.
And what is happening in move elevator?
We're moving the lift to that floor.
So it is not the software that is it will just tell some motors to move it, right? And then it's done.
That is what I'm trying to say, that it will
I
tell the
think he's
motors to
saying कि अगर fourth पहले push कर दिया and then उससे नीचे वाला अगर कोई press करता है तो पहले 4 वाला तो process करेगा ना
so
पहले.
that is why
That
there
will
is a
move.
strategy for that. No, that is why there is an algorithm for that. So right now I am just giving say 5. So you are saying कि I am at say 0th floor and I am pressing 5 4 3 2 1. I am pressing it in opposite direction, 5 different people. But it should ideally go to 1 2 3 4 5. That is your problem.
No,
Correct?
no. I think his main concern is once I say 5th floor, till it goes to 5th floor, that it will not be able to process.
Yeah, exactly. Can you
is
But
what it is.
that is not the concern of the software, isn't it? Let's say your software, your algorithm tells to the motor that okay, you will first go to 5, and when the motor is going to 5, it has already queued the other one. Okay, that once the motor
Correct,
stops, it will go to 4 or 3 or like that. It is none of its concern that okay, unless the motor is stopping, then I will tell it. It's none of its concern, isn't it?
Also, Kirti, if you can go through that sensor wala thing, no, it will become more clear.
So I'll just tell you something. So I know it will get a bit complicated, but just wanted to tell you. So basically, there will also be a sensor. So just like we said that there is say there is a strategy which is saying that okay, we have to go to 5th. We are going up. Okay. Now hardware wise, if you think about it, if I am going up, you can see on the display that if my elevator goes from ground floor to 5th floor, you can see it on the display, right? That I'm going from 1, 2, 3, 4, 5. So how does my elevator come to know in which floor am I?
Yeah,
This
I
is
get
one thing.
that.
So let me just finish this. So there is a sensor, right? Which is basically sensing the current floor. You can think of it like maybe there are say 2 parts of the sensor. There is some say outside, there is one inside, and then as soon as the elevator comes and it knows that okay, I'm here right now, something like that. We are basically detecting the flow, and as the elevator is going to come at a particular floor, as we detect, the sensor can actually check that in the strategy or in the controller, is this a stop? So maybe by like suppose I was going to the 5th and the next request came and I added the request from 5 to say 1, 2, 3, 4. I've added the next stop.
Basically, sensor is notifying all the observers.
Yes. So that is why I wanted to say that there will be basically an observer design pattern over here because my sensor is a subject. It is notifying, but why? Okay, I'll also explain why I did not do observer design pattern, why I thought it will be observer design pattern. So I have a sensor. It is sensing that I'm at a particular floor. It will check with the other elevators or whatever that do I need to stop over here with the controller? That do I need to stop? Is this a next stop or not? And then if it needs to stop, it will stop. Otherwise, it will continue. Why an observer design pattern seemed like an overkill was because who is the one who is actually being notified with the change of the sensor? It is being, who is being notified? Maybe the display is being notified, which is again inside the elevator. Who is being notified? Maybe the controller is being notified, who is again inside the elevator. The elevator is the only one who is getting notified, right? So there was not a lot of one-to-many. And we were not designing for, say, admin and all. And I don't see any use case why admin should be notified again and again that we have reached a particular floor, reached a particular floor, reached a particular floor, right? So Piyush is saying the display will be outside. So there can be 2 displays, internal display, external display. The display will be on every floor. The point is, when do we use observer design pattern? When we want to add the observers and remove the observers on the fly. The point over here is the objects who will be notifying who will be observing will be fixed. Even if it is external display, even if it is admin, there's hardly any case where you would have to add or remove. You remember in the observer design pattern, we saw register observer, deregister observer, notify observers. Here, we do not need those three. Here, I have added add elevator, remove elevator, notify elevators. They can be. But how many times are you going to actually do this? So it seemed like an overkill, but I wanted to discuss this. Rama is asking sensor is part of the elevator. See, sensor, basically you can think of it like, so if the elevator is going up like this, there is something outside which is detecting that, okay, elevator has come to this floor, right? And then we can check that, okay, is this a stop? If it is the stop, then controller will get the notification that, okay, I need to stop. See, if you see the sensor code that I wrote, so this was just to discuss, just to make you think a bit about it.
No,
So
it's
here,
like Kirti, it's like his sensor just detects which floor is it, and it just notifies the controller and notifies then know ki whether it is my stop or not.
yeah.
So to answer, I think it was Tanmay, right?
Yeah, it's me.
Yeah. So to answer your question, so when sensor suppose detects its fourth floor, it will tell to the controller that fourth floor has come. Controller will, till that time, it will be queuing up the request. Then through the strategy, it will look whether 4 is my stop or not. Is it a stop or not? So if it is a stop, it will stop or it will keep moving on. So to answer your question, it is queuing that request.
So strategy is deciding whether I have to go to this floor or not, and controller is deciding, or sensor is deciding that if I have reached this floor,
it is
then
just
is it my
sensing the
stop or not?
no
But we
sensor is
already know the
just
stop, right?
sensor is just sensing the floor and sending it to the controller. That's it.
the controller has this state, right? Set current floor and all of this. So the controller knows that, okay, this is the floor that I'm going to. And then controller knows, okay, the strategy has basically the list of stops, right? That this is the next stop, this is the next stop, this is the next stop. So now controller's work will be that, okay, these are the requests that have come in. Now, if this is the floor, what is my next stop?
Yeah.
So this will be able to tell that, okay, do you need to stop now or not? No matter in which order the request came. And it is not like till I reach the fifth floor, I'm not accepting anything. The controller told the hardware that you start moving and it is processing more requests. And in between that, if it got 1, 2, 3, 4, it is just adding to the strategy. And the strategy is saying, oh, we need to move, we need to stop over there. And then the sensor will sense that, okay, this is the current flow, and the controller will say, okay, stop.
Okay. I mean, I'll take it at the end. I still have a small doubt. So if the class is over, then I'll take it up, or else, I'll just wait if any other person has any questions.
Right. So I think more or less the class is over. See, I've covered everything. Try to go through the code and the UML. Everything is there on GitHub. Just go to GitHub/Kirti Purswani, and you will be able to see the code over there. There's a repository separately for this. If there are any specific questions other than what Tanmay has, let me know. I will answer. I will try to answer now.
Kirti, can you show the controller code? What it is?
You want to see C++ or Java code? I can show you.
Java will be better.
Controller, where is my controller? Yes, that's my controller. So here you can see, so move elevator to floor. Basically, see, there is a strategy and I'm saying move, right? But what is actually going to happen is that this will be connected to the hardware. That part obviously I cannot show in the demo, right? So in the demo part, basically we'll update the current direction, the current status, all of that we are going to set. Here I've written current direction 2 times. One is direction, one is the status, but okay. The point is that the controller is the one that is basically telling the hardware that you need to move in this direction, you need to stop. All of that is the one that is controller is doing. And inside the current state, there is current direction, there is current status, and there is current flow.
Kirti, since the topic came about like multiple requests coming at once, I had a doubt regarding parallel request for external and internal. So, like if the elevator is on the move, so are we dealing with the case where the external request will be dealt separately for a moving lift or a static lift, and shouldn't that status be considered then in the external request?
So that is why if you see the strategy, the selection strategy, that which elevator firstly should come, that is why it has access to the elevator manager. It can see what is the current status of all the elevators, right? That what is the elevator state of all, is it moving, is it stopped? And then this selection strategy will choose that which elevator will come. Okay. And once the elevator has taken up the request, when it will be served, this elevator control strategy will take. So once the external request comes, this one will first select that which elevator will fulfill the request, right? Then that elevator will be told that you need to take the request, and then elevator control will see that, okay, I have added to the, say, the request that need to be fulfilled, and it will get stopped.
So basically, in this process, the external request manager won't have anything. Like they that will be handled only by the strategy controller, right?
I did not get the question. Can you repeat that?
Where if the elevator is moving or stuff, that need not to be checked by the external request handler. That will be checked by the strategy, and that will suggest this which lift to be taken, and then the external request will go to that lift.
Yep.
Is it?
If you see the external request processor, I first see what is the assigned elevator ID from this strategy. Then I go to the elevator manager and I get the elevator, the assigned elevator. Then same thing, I am telling the assigned elevator that you need to move to this floor, and this guy will tell the controller that you need to move to this floor. Internally, it is using its own algorithm or the strategy.
Yes, got it.
Cool. Any other questions? Okay, guys, take your time. See, tomorrow there's a relatively simpler system, chess. I'll be talking about interview tips and like how to handle the requirements and all of this a lot more tomorrow. And day after tomorrow will be a lot more complex system. IRCTC, we are going to talk about multi-threading. It's a really, really complex system, right? So try to take this in and try to ask as many questions as possible on Discord so that I know what are the questions you're facing and we'll try to pick them up. Quick thing that I wanted to cover. What are the design patterns that we have covered inside this? So this is one strategy design pattern, one strategy design pattern. Then there is one singleton over here. There is another singleton over here. This is also a facade. We could have used factory in the creation, but I told you why I thought it would be an overkill. We could have used observer, and I told you why I thought it would be an overkill. Since this is a relatively not so complex system, I've used it like this. Try to go back and think that what other design patterns could be used. Try to ask questions on Discord and I would be able to answer. Yeah.
So instead of factory, we could have also used the decorator pattern, right? So considering private and what other kind of list as an access specifier.
What are we decorating?
So basically your private lift would be an access. So it's a lift which goes only from 0th floor to 13th floor. It's a lift that will only carry goods for your goods for your people or people who are service people. It's a lift which will only carry the general passengers.
So do you want something like that? It's a service lift. Then you are adding that, okay, it can go only to this floor. Then you are adding that only this is possible.
Yeah.
If that is the
I
case,
don't think
yes,
decorator is good here.
but seems like an overkill, honestly.
Yeah, I would for this what he's saying, I would use maybe a proxy pattern. You give a request to a proxy, and proxy will decide what to do and then actually give it to the actual object.
Yeah, right. That's also a good way to do it. Okay. Now, can I ask a question if everyone's done?
Is anyone else has any question?
I had one doubt. So the processor itself directly gets the elevator, right? So is that okay, or should the manager be the one to like talk to the elevator. So in our case, we are just getting the elevator directly, right?
In our case, like I thought it is fine because I wanted to keep the responsibility of elevator manager just to keep the map of the elevators, just to store the maps, and not to actually do anything like with the elevator. And request processor, like the responsibility itself is to process the request. So it is fine if it is talking to the elevator. That was my thought process.
Okay.
Any other questions anyone has? Cool. Okay. Please show up the next 2 days. I will take your question, Tanmay. Everyone else, please show up for the next 2 days as well, and for the next week as well. With these discussions, I guess you will also get to learn a lot. I'll also get to learn a lot. The best part about live interactive course. So please, I want better attendance. Yep. Thank you. Please go sleep. Like see you tomorrow and after. There will be no notes and yeah, tell me.
एक बात थोड़ा आपसे बात करना था कि एक्चुअली मैंने ना रैंडमली 2 कोर्स अप्लाई कर लिए थे बोथ, तो मैंने मेल भी करा था आपको, तो वो प्लीज आप कंसीडर कर लेना जैसे HLD शुरू होगा तो लाइव क्लासेस में.
हाँ, तो I think I had replied to you. You wanted to attend the next live HLD class, right?
Yes, ma'am.
So whichever, like if you have applied for HLD, you will get access to the next HLD as well. I had replied to you. So like this also LLD, it is not just like if you're attending this, you cannot attend the next live course. Whenever the next live batch will happen, like for HLD, if you have applied, you can attend the next live batch. You can attend any live batches. Similarly for LLD also.
Thank you, ma'am. Thank you very much. Thanks, ma'am.
Yep. Cool.
Kirti, can you please explain tomorrow, like how to cut short? This is like very huge to explain in the interview standpoint, right?
So initially I wanted to go full-fledged in, then I will also talk about how to cut this short, how to manage in an interview. We'll do all of that.
Thank you.
This is to give you an idea how the extensive low-level system design works. See, if you do for a company, if you work in a company and you're doing low-level system design over there, then you have to be this extensive, right? You have to think about it.
Yeah, true.
So I have to cover both the things. So that is why first I'm making you think like this, and then we'll also talk about that.
Yeah. And again, for your DSA course, I have taken both of your HLD and LLE. Is there any extra discount apart from 1,000 rupees?
So actually, it is, then I would have to keep track of a lot, right? Because there were boot camps also before that. And there will be more courses that will be coming up. So I'm just giving discounts for the one who have attempted like previously. So for those who attended HLD and not LLD, they did not get any discount for DSA. Like it is like that only. So for any course, I am giving discounts to the previous course participants like that.
Okay.
Yep.
Okay.
Like for... Sorry?
Yeah, nothing. Started.
Yep.
Please go on.
Yes. By the way, the curriculum and everything is over there. Like FAQ section also, I get so many mails without people checking the FAQ. So if you have any questions, please check the FAQ section, the curriculum. So this is 6 weeks and it is a longer course. It is of 4 days a week because the more we practice DSA, the better it is. I know it is intense weekdays and all of that, but honestly, if we stretch it a lot, you will lose interest, right? So, and these are extremely important topics, the 4 topics that I'm covering: recursion, DP, trees, graphs. So I think once you cover this, it will be completely done, right? Like you won't have any problems in DSA anymore.
All advanced topics, I believe. Yeah.
Yes. So we'll start from basics of recursion, basics of trees, basics, but I won't be covering like say basics of arrays or basics of math. So I've already mentioned that in the prerequisites.
Ma'am, resume preparation भी आप करवाएंगे क्या?
Not in the course.
Like हमने 2 कोर्स पहले ले लिए. One we will also apply for DS as well. 3 हो जाएंगे तो resume भी आप apply. Actually हमें कॉल ही नहीं आ रहा. मेरा actually have experience of 10 years. तो मुझे कॉल ही नहीं आता है. I'm working in service space.
Okay. Can you probably mail me your resume or send it on Discord on networking? Like we can probably, like others can also review it. We'll also review it. And if you need help contacting someone, also, by the way, I think tomorrow I will be releasing say certificates because a lot of people were reaching out that they want certificates of completion. So that might also help. Plus, if you need any endorsement, if you have attended multiple courses and if you need endorsements on LinkedIn, I can do that. Maybe that, okay, this guy has attended, has good knowledge, something like that. That might help you get calls. And if you want to get in contact with someone on LinkedIn, I can help in that sense. So if you are attending multiple courses, I would try to help in any way possible. But yeah.
मैम बट आप पहले एक्सेप्ट करोगे रिक्वेस्ट तभी तो आप एंडोर्स करोगे ना. मैंने आपको रिक्वेस्ट भेजा था, आपने एक्सेप्ट
Yeah, request see 30K matlab I have already crossed it long back.
Okay,
30K
okay.
is the maximum connections. If you want to be endorsed, just mail me separately. I
Okay.
will get it done. Na aap logo ke liye to I am always available on Discord, right? I've always been like replying. I think I am most active on Discord than any of you. So unless you ask me on Discord, I won't be able to reply. So please ask if you want to be endorsed. Probably work, like maybe show me any code that you have written, how much you participated, or anything like that. I am sure that you were attending the classes. So that should be enough.
लीड कोड में मैम मेरा स्कोर है कोई 3200 है. आप सोच लीजिए कितना करोगा.
And I think now I know you, right? I've seen you ask a lot of questions. So I will. So just send me your details on Discord or mail me and I will do that.
तो मैम 10 ईयर एक्सपीरियंस पे ऐसे क्वेश्चन होगा या कैसे, मतलब बट रिक्वेस्ट में मुझे कॉल बहुत कम आता ही नहीं है.
So what happens is that LLD is expected from freshers also, from 10 years of experience also, from 5 years experience also. It is extremely important, especially in the starting years, say 1 to 5 years of experience, because that is when you do most of the coding, right? But for more than say 5 to 10 years of experience, I think HLD is more important. For 1 to 5 years of experience or no to 5 years of experience, LLD is extremely important because you need to be able to write code, write running code, and be able to demo it properly. So LLD is very, very important in that case. You have to practice, like you have to apply design patterns also. The level expected will be different. Like from a fresher, obviously they can't expect design patterns and all of this. But from someone with even 1 to 2 years of experience, they start expecting everything. So yes, proper naming, proper design patterns, proper how do you write code? Do you know about different relationships between the classes, aggregation, composition? All of this will be seen.
Okay, ma'am.
Yep. Cool. Great. And no need to call me ma'am. You can just call me Kirti.
Sure.
Kirti, I have a question. So you have covered recursion in your YouTube channel also, right? So will the DSA course have topics other than that, or like how much it will be different?
So recursion is there, but here, see, firstly, it is live, so it is going to be different. But in like over there, I just covered basic recursion questions. Like here, it will be like end to end, and we'll also. So I don't know if you were part of the bootcamp. So in the bootcamp also, we covered this. We did visualization of recursion. Then how to convert this recursive solution to DP solution. First of all, that is very important. So once you understand recursion properly, the DP, the bottom up, the top down, how do you convert it from recursion to DP? How do you do space optimization? So the entire thing is like linked. So we will start from basics of recursion. Like, so even if someone is beginner, they will be that will also be covered. But we'll also talk about advanced level things, that how do you convert this to DP? How do you do the space optimization? And then also, because we are covering trees and graphs, so there are some combination questions also, like tree plus DP or graph plus DP. There are few typical questions, so we'll try to cover that as well. So hard level concepts as well.
Sure. Thank you.
Cool. So if you already know the recursion, then maybe starting 2-3 classes might be like easier for you. But like I would still say attend those 3-4 classes also, because then you will get your basics right, because recursion is the basis for DP, for trees, for graphs, for everything, right? So recursion is extremely important.
Sure.
Yeah. Cool. Okay. Any other questions?
Yes, I'm going to ask question. I'm waiting for his questions to understand this.
Anyone else has any questions?
Same here, waiting for Tanmay's question.
Okay, Tanmay, go on.
Pressure में डाल रहे हैं लोग. Okay, can we go to the main class of Java, right? So I'll show you what I'm trying to say, right?
Okay.
I could be wrong here, but as far as I know,
Reviewers बहुत हैं, अभी चिंता ना.
Okay, so what is happening is that see, let's just run this, right? So send internal request me. Let's copy paste line number 15 and 16. Paste it again, right? Yeah, paste it again.
Also, please note that this is a demo, like hardware
Yeah.
is not connected to it, right? So you won't be able to replicate that, okay, I am accepting requests while the system has started moving like that.
Correct. Okay, so it says that, wait, what? The direction is down, our source floor is 6, let it be. The internal request says that we are at 4, then we go to 7, then we are at 4. Let's go to what, 5, right? So line number 18, let's make it 5. Can we run this now? This might be wrong, by the way.
Right now, I'm not written the algorithms also, by the way. So
Yeah, so see what is happening is now one more thing that you can do is the way I want to explain it to you is you see you are doing a CISO of a dotted line, right? So that would mean that we'll come to the next line as and when the entire internal request has been completed. So
okay,
it is
give me 1 sec, okay? If I change this output statement from moving elevator to add its stop to. So if you say it like applying this algorithm and add its stop to floor number this.
yeah. So my question would be the strategy, right? So now there could be two ways to answer this. One way is in an interview, I'd directly say that my strategy is literally giving you the number of floors you have to give to the hardware, and then hardware is deciding whether it will go to the 4th floor first or it will go to the 8th floor first.
Hardware will not decide. My strategy.
Hardware will not decide. Your algorithm, your strategy will decide
Yes.
it.
But for your strategy to decide, it should know before. So your strategy should work in ASM mode, right? That is what I'm trying to say here.
Okay. Let's say, so let's do a dry run, for example. So let's say right
Yeah,
now
let's
my
do
queue is empty. Okay, so there
Okay.
is no request coming, nothing.
Mhm.
And then first request come, and it is, let's say, request number we are taking only one elevator, right? So that we don't confuse, only one elevator.
Mhm.
So the request came that currently the elevator is at 0, floor number 0,
Mhm.
and it has to go to floor number 4.
Mhm.
While it is traveling to floor number 4, before
Mhm.
reaching, like in the meantime only another request came that it has to go to floor number 3 or floor number 7 or whatever it is.
Mhm.
So your function, it took the request that, okay, it has to go to floor number, the next one, and it, through that algorithm, it gave the response, okay, what should be my next stop?
Yeah, exactly this, right? So the problem here is that you already convey to your hardware that you need to move to floor number 7.
Yes,
Now your
while it is
hardware,
moving, I
while
have not interpreted it. I have not
Correct.
interpreted it at all.
That is what I'm trying to say here, right? So while it is moving,
Yes.
you're trying to process the second request.
Yeah.
Makes sense.
So what's, yeah,
But
fine.
yeah, and you're relying on this faith that your second request will get processed before you reach the floor where you want your lift to stop.
But
In
no.
any case scenario,
Why? I'm not relying on that at all. The moving of the elevator has nothing to do with the what we say, that the algorithm. The algorithm is only giving you where to stop next.
Algorithm is giving me where to stop next.
Where to
right?
stop next, right? So let's say when I reached floor number 7 or something, the algorithm hasn't processed yet, or maybe the algorithm has processed a long time ago. In either cases, either the motor will have something like where it should go next, or either it will have nothing.
You are coming to the hardware part, right? So I asked you this question, whether you want your software to already know that, okay, you need to go to the floor number 3 first, then 5, then 7.
That's
right?
what our algorithm is doing, right?
That is what I'm trying to say. Your algorithm does not have the context of any other number. It is just getting the context of a single floor.
No,
it is getting the context of the queue. It is not getting a single number. It is getting whatever is the current instance of my queue.
See, inside this algorithm, as I said, it might be storing in a queue or a stack or a priority queue or wherever it wants, and it is storing. And like if the elevator is moving in a particular direction, this guy is telling you that, okay, this is the priority, this is the next stop where you have to stop. So it is telling the controller that this is the next stop.
Okay, Tanmay, will it make sense once request
Yeah, I
comes,
got that. So, yeah,
once a
got
request comes, I just put the strategy in a different thread and it is working on a different thread. Will it make sense?
yeah, that is what I was thinking about. So
Yeah.
basically,
So
the move elevator should have been add to
see,
something.
yeah. So move. Yes. So that's what. Like you can put that in a different thread, total strategy thing.
So actually, I think I renamed it in C++. So it's only, give me 1 second.
That's okay. But yeah.
So if you see my inside this, when I go to move floor, I go to my controller. Here you can see that here I have done determine next stop. I've renamed it for to avoid the confusion. So
Yeah.
I'm just determining the next stop instead of move. I
Mhm.
should have renamed it everywhere.
Now it's
I
clear, all
understood
clear.
that, okay, the doubt will come, and that is why I renamed it in C++. I missed renaming it in Java and in diagram. I will do that. Here I am determining the next stop, but my strategy inside has the information of all the requests that are coming in as they are coming in. And the strategy, the algorithm is deciding that who is my next stop. So determine next stop is what I'm doing instead of moving.
Got it. And
Uh,
after
Kitty,
The things that one wrong renaming can do to you. So yes. Cool.
And Kirti, also one thing more. You talked about that sensor is going to tell me. So can we print that it is going to stop now? Let's say if we have multiple main strings, like in main, if I have multiple places to go, if multiple requests are coming, and then there's a sensor which you have built, right? Which will tell me which floor I have reached on, right? And whichever floor is in that queue. So then that is more of like implementation I'm doing into the algorithm, or like when sensor reaches that floor, and if it is a part of my queue stack,
You
then
can
it's
just say that if it is the next stop in my controller, I can just check, is this my next stop?
and
Right.
print it, and I print it onto my screen.
But
So
then I
I
have
think
to, like, how do I demo the sensor part? No. Otherwise, I'll have to like add some say time gap, and I would have to say, okay, now the sensor is sensing floor 1, now it is sensing floor 2, now it is sensing floor 3. Then I will say, oh, floor 3, this is what the next stop was. Then stop.
so basically, you mean to say that as and when the more request comes, you are after using the strategy, you are stacking it into a queue, that which all stops it needs to go to, the left needs to go to. Now the implementation where it is to stop, that is not getting covered in this, right? In that this code, that is not getting covered. You are just saying that which all that is the hardware part, but you are just leaving to that extent, not going beyond that. That which all stops it needs to stop on, right? But whether it will stop or not, that is not covered. I think that was the doubt of Tanmay, that how will that be executed by an hardware, that if I'm going to 7th and in between I get a request for stopping at 4th, somebody has requested to go till 4th, from 0 to 7 I'm going, and there's a request which has got stacked for number 4, but that will get stacked and that has not been implemented in the code, right? That is what we understood, right? That was his doubt also, right? Tanmay's doubt was also that how will that be catered, that if it is going till 4th, I mean, like, in between a request comes for 4th, then will the system show, like, we are doing demo, so I think we are not printing all that stuff. We are just saying that where to go and stacking it into a queue. That's it, and finishing our code.
Also, I have to prepare demo for 2 hours. I have to like discuss and then explain the classes. Like,
No, I'm not denying. I'm just saying that why his doubt came in, and where did we stop, and he's thinking beyond that, right? So demo is still that part only, right?
My doubt was at move stop actually. So that wrong naming made me thought that we are calling the move function and then
And it
moving
should
back.
have stopped at 4th floor also, and then like whichever
Yeah.
floors are coming in between, right?
But now I think, right? So one change that we should do in this design would be instead of calling for a single floor that I have to go, I already know the number of floors that I have. A list of inputs have already been given to the internal request manager already. So why do I want to increase my status and make the entire call again and again and again? Why not just pass a list of floors itself?
see, because the way you want to deal with those list of flows will be different. In one strategy, I'm keeping it in priority queue. In another strategy, I'm keeping it in stack.
Doesn't
Or a
matter.
normal. See, how I want to also decide this runtime for a particular system. In a lot of systems that are available on code, you will see it like this. You will not see algorithm, you will not see strategy. You will see, say, 2 priority queues, one for going up, one for going down. And then you will just keep inserting in it. Okay, if this is there in the priority queue, we'll stop there. That is a simple. So if it is, say, a half an hour interview, 1 hour interview, that is what you can do. It is sort of a DSA also. That you will write 2 priority queues. One will be for going up, one will be for going down. And you can do it like this. You will find code like this online. Okay. But what I wanted to show was that in a system, say if I have in one building, I want to use one algorithm, another building, I want to use another algorithm. How can I do that?
उसमें भी in a building for an elevator system, my algorithm is fixed for a certain period of time.
But then they can be different algorithms, no? And my admin can set that I want to use this algorithm or that algorithm.
For a set of वो तो I'll always allow, no? But let's say internal request now, what I'm doing today is when I press 4, I go through the entire UML diagram for that matter, come back, then I press next button, and then I go again and come back again, right? So all I'm saying is instead of passing floor to the request, let's pass the list of floors that we need to visit, right?
Instead of passing floor, list of floors. I did not get that part. What is the list of floors?
So what we're doing today is, let's say I enter the lift first, I press 4, the system will process it for 4, and then you press 7, the system will then process it for 7, and so on and so forth. All I'm saying is, at a floor, given floor, when lift opens and closes, we already know before we are moving to the request part, we already know all the floors we have to go here.
No, not necessary. The lift can start moving. I can press again.
No, then we already have that single wala thing, no? I'm just trying to.
But okay, so you're saying that instead of one floor, I can pass a list of floors. That
exactly.
Once I'm getting multiple, you can do like that. So that instead of one destination floor, you want to pass list of destination floors.
Exactly.
In internal request, you can do that.
So, Kirti, I had a doubt very similar to what Tanmay is asking. Like in the move, shouldn't the lift not take the input or take it, process it later when it gets to a current floor to check if the floor has been passed already? What I am saying
It is
is
not
if
moving at that time. Just remember, I am determining the next stop. I am not moving. I am determining the next stop, and then
the current state of the lift should also be taken into consideration when we are determining the next stop,
that
right?
is why my controller has the state, the elevator current state. That is why my elevator has current state, the current direction, the current status, the current floor, right? But there's a level to which I can show, right? So this is what I was trying to show, that controller has elevator state. And based on the elevator state and based on the next stop and based on what sensor is telling, the controller is the one which will decide whether stop or not. That point is correct, that in my internal request, you can send, say, multiple destination flows together. I am pretty sure if I would have done that, then the request would have, then the question would have come that if I press one by one, just think of it, no one is going to press at the same time. If I press 1, 2, 3, 4, okay, I am waiting for 1, 2, 3 to get processed until I have entered all 4. How are you actually going to make it work, right? So
basically, it's till the time the lift is stationary, whatever entries come, that goes into the list, and then that list gets passed.
Right. So there's a lot of hardware involved, right? If the button is being pressed, button is being pressed, button is being pressed, button is being pressed, then you wait that, okay, now it is moving. Now I will take the request. If I would have showed you that, then you would have also had the question ki, we are waiting. Why can't we just process by the time one has been pressed? We should process. Well, let me tell you. Okay, let me give another example. For example, 5 people came. Some people pressed for up. Some people pressed for down. Right? Now, based on the current status and based on the requests that are coming, I should be able to say that, okay, you start moving. Now people will keep pressing.
I think it is okay to take single request at a time, not like a list of requests.
I am not against you should not take a list. It is okay to do that also. I don't see any major improvement from this design, like in that. What is the major reason of you adding a list instead of that?
List and the request.
No.
Correct.
So if there's a pause, then waiting time, you are increasing more complexity to know how, when to say that that list is complete, right? When you say that it's a list, when do you say the list is complete? You cannot wait till eternity. You need to have some cutoff time to
I
say
can
that,
have
okay,
a TTL of 5 seconds, 2 seconds, 7 seconds.
so that is what I'm
So
saying. Then that has to be built. The
Then
system
you are
to
adding complexity, no? Then you are adding complexity, that you are saying that I am going through literally three classes, 1, 2, 3. I'm doing 3 to 4 calls.
you're doing DB push also, no? Pushing into your stores.
Firstly, there is no DB.
There is no DB. It's all
You
in
have a store, right? These
It's all in
strategies
memory.
have a store. It could be a local store or a DB store.
No.
No.
It's
Why
all in
would
memory
it have
only.
all
Why
in
do I
memory?
need it?
Then this is one, I would say, standalone application, right? It is not a
Yeah, it doesn't need to store any data like whatever it has already processed, right? So it only needs to keep the data which it is currently processing or
Correct.
need in future. So the size will not be that much that you have to
आपके
store it in DB.
वो RAM में ही काम हो जाएगा, तो
Heap memory
DB
में तो
process
भर रहे हैं ना, we are filling it in heap memory ना.
अरे वो तो मेमोरी ऑब्जेक्ट
वो
उसी
तो
एप्लीकेशन सर्वर के अंदर ही है ना, तो
वो
you don't
RAM है,
have
RAM।
RAM ही है, RAM में इतना पंगा नहीं होता है.
And then compared to that, you are adding a TTL, you are adding the check on the hardware that, okay, these buttons will come, these will get pressed. You look at the pros and cons, trade-offs.
Kirti, only one thing.
Besides,
Sorry, if Tanmay is done, then I'll ask something else.
No, mine is done. Just ask.
Also, one more thing here, like maybe if you are implementing a system in a real project where you have the requirement like this, maybe you can design it. But let's say from an interview perspective as well, you don't need to go into so much complexity, right? Because you won't be able to cover all the cases anyway.
See, also, like, I am okay with your thing. I'm not saying I'm against it. I'm saying you should be able to give me a good enough reasoning. And right now, I've not received good enough reasoning. Like, you can think about it later. Tell me a good enough reasoning that how would you deal with it, sending a list. I am okay with it. Think about it. Tell me on Discord. Tell me tomorrow. It's okay. Discord preferably. Tomorrow we have another system to discuss. But
I can think of one right now, in the implementation that we have currently, that is first come, first service, right? If we think of the other strategy, getting to a floor and checking whether that has to be taken into the priority queue where it has to be taken. That will be more don't you think that will be more better if we have all the inputs already instead of computing it and then evaluating where it has to be placed on the basis of current floor every time?
Okay, let's say we are doing in a priority queue. Will you add all five requests in a priority queue simultaneously, or will you add one by one?
It will always be unlocked in.
No, it's not about being better. It's about how a real system works. It cannot just wait for things to accumulate all the requests.
Yes.
End time. What will be your end time? That is the point. Na? You are saying that I will wait. What will be the end time to say that, okay, no more requests are going to come now? What will be the cutoff?
And the question over here is not to optimize the algorithm. The question is to optimize the system.
Kitty, I have a question. So this determine next stop, that should return something, right?
It is returning integer, which is the floor number. Determine next stop. So if you go inside this, sorry.
Okay, sure. Since we were not storing, I got confused. So it will be like controller will get this and it will ask the hardware to move. So controller will take care of that, right?
It's a good thing that you guys are thinking so much. If you look at any elevator online system, no one has discussed till such detailing. Go through it. I challenge you, go through all the online solutions and you tell me, this is a good thing that you guys are thinking so much.
Kirti, one question.
Sure.
I couldn't still find that indirection which you created for internal process request. That indirection
We
which you have
talked about
created.
it, no? That it is in the demo itself, like over here in the main itself. I've created like this. We talked about it that there will be buttons. So there will be an external button. So if the external button is being passed, then this is the request. If the internal button is being passed, this is the request.
No,
You
no,
can
no.
also
But
keep
why
an,
do I?
you
Why
can
why can't why can't I directly call? Like I'm just passing on the request to right, and then again calling the event manager back.
Why do we have a facade? Because we do not want our client to know about it, right? It is
It's more
okay.
abstraction, more for abstraction purpose. You were saying that you have routed it to indirection. Well, I call it indirection. Indirection sense that I'm sending it to it, and then it is calling elevator manager. So it creates an abstraction for the class your main this thing manage service class like
For
and
the
the one
request
which you
processor, no, for the request processor. So
and
our client
what
doesn't
you
know that there are request processor. Client
and
knows there is elevator system.
actually, and then what you're calling elevator system normally in the application, is it called the service class? Is it just the service layer? Because wherever I am when I studied earlier, this is what a service is like from the MVC you call a service, and then this service is going to further get all the objects and all that stuff and do the things.
Yeah, it's like the outer layer which is getting directly
Service
the
layer,
user's
service layer.
input. Yeah.
It is a service layer, right?
Yes,
It is
yes.
simulating service layer.
Yes.
Okay. Fine. And Kirti, one more thing, like in demos, what I feel is when you write the client, what happens is people get confused to that in client itself, in the main method, we are calling all of it, right? And people get confused it if we have to write it there. I get confused, although I understand it now. अगर हमें वहीं पे सब कुछ लिखना है तो client ही सब कुछ बता रहा है तो how will that happen? So मतलब maybe just to give one demo of that will be a front end to it, and there'll be a request coming from a server or a button from front end, and then it will
That is
get
why
routed.
I think like that is why I'm telling no, okay, button is being pressed. This is what is happening. Like, see, already in 2 hours, how much will I cover? And we have to cover multiple systems. You want me to
Just
add front end to it, then
my
people will start asking about front end.
no, I'm just saying फ्रंट एंड मतलब आप उसको ना डायग्राम में ही बेशक बता दो स्टार्टिंग में कि ऐसे ये जो मेन है this main is nothing but a request coming from front end which internally is getting which I have simulated into my main. That creates problem like it will give more clarity to the freshers or them कि भाई this ये main एक demo ही है मतलब still main is ऐसे main नहीं होता अभी लोग सोच रहे हैं कि यही main होता है main ऐसे ही आएगा client से request main से ही आती है अभी सबको यही लग रहा है.
अच्छा ठीक है okay noted.
Although in this system it will be from a main, if you see it will not be like a proper server or front.
This is a standalone application.
Correct.
It is a standalone application, so see, I can relate it because I have seen. I can understand that main ऐसा नहीं होता. मतलब client request ऐसे नहीं होती, main की तरह नहीं आती है. So that, but for others, I'm just saying those who have not been in IT industry, मतलब I've been in IT industry, so I understand now. उनके लिए थोड़ा सा challenging हो सकता है मतलब just but it was challenging for me earlier, so now that's what I'm assuming for others.
Got it. Okay, cool. Okay, guys, please get sleep today because 2 more days and then 1 more week. I don't want the attendance to go less, so please get some sleep and ask questions on Discord now.
देखो जो अभी तक जगे हुए हैं ना 23 participants वो तो आएंगे.
Please
others have gone.
stop attending the classes like after this.
Okay, thank you so much. Thank you.
I love the discussion though. My point is never to discourage you or anything like that. Attend the classes, yeah. Like
yeah. Okay, thanks.
All
Thank
right.
you. Good
Everyone,
night.
good night. Bye. Good night.